but
just have no
run
data.
something that's
I'm trying to figure out. Right now, I'm leaning towards using a wave, like a linear style textbook. And for programming classes, to more getting I'm going to try it next semester. Like a reference text.
This looks better than Sean.
So yeah, basically a reference that has everything you can use on that language. And then making the classroom. But I don't know. We'll see how that's going. And on that, go back to
next class. Yeah, and it's one of the things that you only ever do.
yeah. I use most of those. The assignments I kind of tweak. Like some of the projects. I didn't want to, I because you have that assignment as a site redesign. So what I had to do, yeah. So what I can do is go on the way back and find a website from like the 2000s and use the response. I'm going to do that. Kind of recreate it.
It was. Yeah. Yeah. It's one of the things that I've shared with you. I've been working on it for what?
Yeah, some of those have been using.
Yeah.
And it's interesting because even though really great programmers struggle with it's so difficult. It's really more like there's configuring the browser and like writing it's a completely different way to think. But it was not, it was several years ago. It was good for me to get a professional.
Yeah, we'll just need to.
Want to join us, Professor?
Well, I need to keep it.
He's already,
Gonna be up there.
I'll probably be back here as much as I can.
I don't think it works. It won't work. Wait, really? You might have to plug it.
Oh, we have to here, Tacker.
It's still on the. That would make sense. Oh, okay.
You're gonna like that though. All right, well, thank you all for joining. So this is the first of, I lost track, how many, the next 4 hours of presentations of senior seminar projects. And so this is the Union University Scholarship Symposium. So we have 10 presentations from computer science and 2 presentations from physics this afternoon. And there's evaluation forms on the table, so please fill them out if you can for any presentations you're sitting through. And we'll have snacks in a little bit. We figured you all just had lunch, so we didn't want to fill you up and let you fall asleep at 3 o'clock. So to kick us off, we have Tacker, Nash, and Jacob Moore, and their project Watchdog, an analytical system for the hub. So hello, welcome.
Starting off, I just want to say thank each and every one of you for being here. It means a lot, and let's get into it. So, my name is Tacker Nash.
I'm Jacob Moore.
This is our senior project, Watchdog, which is an analytical system for the hub. All right, so there were some problems with the current implementation in the hub. Faculty lack insight into hub activity. Currently, faculty can't accurately determine important metrics. Metrics such as exactly how many students came into the hub, when they came into the hub, where they were, etc. And the current solution is insufficient. Right now, they use a Ring doorbell camera, and I think we could do a little better than that. So, moving on from there, you can, with the Ring camera, you can obviously sometimes identify the people, right? You know, it's motion activated, you can sometimes identify them, but most of the time you can't really put a face to a person. And brings us to our next problem. So existing solutions are costly. We were looking into, Union as a whole was looking into potential solutions for the hub. And as y'all know, we use Verkada Pass, right? We use Verkada as a vendor. And so naturally, Union tried to look into them for a security system of some sort as well. And after talking to Professor Glass and Googling how much they would charge, it would be roughly $500 to $3,000 per camera. On top of that, there's an annual subscription for $200 to $1,800 per camera. And, you know, Professor Glass came to us, we talked with him some, and we wanted to try and tackle this challenge of bringing along an affordable and modular solution that gives faculty insight. And so that's how we kind of came up with our solutions here. So, like I just said, faculty will have insight into hub usage. Using the dashboard, faculty, chosen by Professor Glass and Dr. Pingen, will be able to access the dashboard. They'll be able to see a variety of metrics, which we will cover here shortly. And using those metrics, they can take action on how to improve the makerspace. Real-time hub activity monitoring and logging. Anytime an individual walks in and is picked up by our system, their face will be logged with different metrics like when did they come in, which camera picked them up. And we also are going to run a web scraper in our system. And for those curious, it's a little nerd side note, but it's for the Prusa 3D printers. We actually got credentials from the faculty over the hub, Dr. Pingen and his wife. And we run a scraper that scrapes the Prusa website, which are those little printers in the hub. And we're able to tell when they were last used, what they last printed, and other metrics like that. So we're trying to combine all these different ways so we can tell, okay, what is actually happening in the hub. And finally, our solution is cost effective, especially considering the competition like Verkada. Our solution is also modular, and our solution is able to scale as needed.
All right, so let's get into the overview. You might be asking yourself, how does this system actually work? So we have 3 main components, as you can see, using the Pi 5 with an AI camera, a POV switch, and a Mac Mini. Starting with the Pi 5 AI camera, it uses several different libraries that I will explain to you as we go on. Sorry, I have to bring up my notes. It's quite a lot. So the Pi AI camera obviously will detect faces. Now you might want to ask, how exactly does this do that? So it runs a local interface using a library called facial recognition. Really on the nose, I know. But we found this as an open source library because it was written by someone way smarter than we are. And we are not dumb enough to reinvent the wheel. We probably would make it a square by accident anyway. Then it also uses its own, the PyCam library, to utilize the AI chip within the camera. OpenCV is also used. We can also use OpenCV to access the camera within a computer that you run the software through in order to test facial recognition, so you don't have to get it hooked up to a Pi to make sure the code is working. This will save you a lot of trial and error. Trust me, as the guy who's been messing with a lot of the hardware recently, you're going to stab yourself a lot on the pins of the Pis if you're messing with it too much, and it does not feel good at all. And then finally, we use another library by the name of YOLO, specifically YOLO V8, for person tracking prior to facial detection. So it's able to recognize when a person is coming through, and then it uses the other libraries to find the face. We utilize a way of finding the person and then deleting that person from the system, and this heavily reduces the computation that is needed for the process to be completed. Going on to the PoE switch, it really acts as a gateway. We power the cameras and the Pis all with PoE, so there's only one cable connecting to it. It also allows for data transfer between the Pis to the Mac Mini, which is also connected to the PoE switch. Getting to the Mac Mini, it acts as our server. Obviously, we wanted to make it cost efficient. We really wanted to make it the most efficient data-wise. We could have gotten a Catalyst 9200, but as most of y'all probably know, a refurbished version of that is about $2,000, and that makes it pretty expensive, especially for a college senior project. And so the Mac Mini runs our database. I'm trying to remember the name. It uses MySQL to run our database, and then also runs the API, which we will show you here shortly.
Yeah, so like Dream just said, it also uses Flask, which is a Python web framework, and we use that to hit the APIs with Flask to add, simple CRUD operations, create, read, update, delete, for the dashboard that the faculty will be able to see. The Pi5 with AI cameras also so the AI cameras themselves have a chip on it, which allows us to actually run, we don't have to run, like a tiny YOLO model. We're able to run a full YOLO model with that. So moving on, this is the home of the dashboard. Right before we came here, we wiped it, and Jacob and I put ourselves in the dashboard, which you will see here in a second. But it has some metrics here, such as how many faces were tracked, vibration readings, which we will get to here in a second, how many were tracked today, how many total detections today. And as you can see, under the 35, there's only 2 entries, but we were detected 35 times by our system as a face in the system. And latest device ping, that deals with the vibration sensors, which we will cover here in a second. And we have some other metrics here, like the top detected faces. It detected mine 33 times, because I was really close to it when we were taking the picture, or when we were getting detected. And you can also see when it was last detected, and the source. So, like we just showed, we have 3, as of now, 3 cameras. So obviously, you might want to know which angle the camera picked up that face from. Here is a dashboard that shows the faces. There's me smiling right there. And you can see, just the detection. And this is not the facial detection. Let me specify, this is a body detection. The facial detection is not, shown here because we thought it would be more valuable to have a whole body detection. So professors or other faculty can go back and be like, okay, if something did happen, this person was kind of responsible. So there's that. And like I just said, when they were last seen, and the source of the camera.
All right, running into prototypes. So this also deals heavily with a lot of hardware, and any of you guys have dealt with hardware, there is a lot of trial and error. If you look onto the left side of your screen, this is the Pi camera case. This is the latest prototype. We are hoping that it would be a finished product by today, but a few errors by a few millimeters was the deciding factor on whether or not we were able to present it as a fully working model. I gave you a picture of the Pi cams to show you exactly what they look like and what we're working with. Obviously not to scale. If the cameras were this big, they'd be a lot more expensive. So the newest prototype was helped designed by Jude Lampley, one of the engineering students. He took the proof of concept model that I had last semester for those that were in our seminar class that watched our presentation. It looks a lot different than it did back then. That's because this is new and improved by an engineering student, because he was like, sorry, but yours isn't as effective as it could be. And so the new way that we have it working is this part down here is a little plate that will sit on top of the Pi camera case. It will snap on, or really it's going to be press fit onto there. And then you will fold the ribbon cable in this area right here, the little cavity, and then feed it through this hole to come out this side. There are some tabs and then a little resting plate for the camera, because this part right here is a little bit off of the plate of the camera, and so it needs something to keep it from wiggling around inside and damaging itself. And then a second plate, this one, goes on top of the larger plate and holds it in place and allows to make sure it doesn't move and it doesn't get off kilter, and will only pick up a certain cone of what we want it to see. And then going on, the vibrations that Tacker mentioned earlier. If you look at the code, this is only about 7 lines, but it's probably only about 96% of the total code. Even something as small as a vibration sensor takes up a lot of code if you really let it, especially when you want to get pretty in detail. The rest of the code really deals with time detection, making sure it's connected to the system, and then there is a complete other sheet of code that the Mac Mini runs to make sure it's receiving all the data that is being transmitted. But the 7 lines really just tell you, hey, this is a vibration detected, and then it just sends an alert. The vibration sensor we use down here hooks up to an ESP32 board also shown. If you're wondering where exactly on the topology this lands in, unfortunately, this would have to be wireless, so there's a little bit more risk and a little bit extra oomph that has to go with it. But it would go and transmit directly to the Mac without having to go through the switch at all. And so, since it is completely wireless. We also have plans to introduce temperature sensors in order to track usage of the laser cutter in the hub. And the reason we want to do this is we want to make sure that we are able to track usage of as many machines as possible to give better insight on what is popular and what is not, in order for faculty to upgrade the hub and say, hey, maybe we need more 3D printers, maybe we need more embroidery machines. The embroidery machines specifically are what the vibration detection is for. And so we wanted to make the system as robust as possible to gather as much data as possible and have it in one specific location to be easier to monitor via faculty.
All right, that being said, here is our acknowledgement slide. Obviously, God is number one, of course, and Professor Glass and Professor Thatcher have been really helpful with this project as well. So has Dr. Pingen. And like Jacob said, Jude Lampley is an engineering student, and Bobby Perry, who's also an engineering student, has really helped us as computer science people with more of the hardware stuff. So, that being said, are there any questions? Yes, in the back.
There are multiple entrances into the hub, and y'all consider expanding the video camera system to those multiple spots, or is that not?
Yeah, so the plan right now is to have different angles. So one camera can be in the corner when you're entering the hub. One camera can be in the corner next to the laser cutting machine, and then one camera can be in the corner that's right here. So you can have multiple different cameras in multiple different angles. And the way our system is built, they're able to talk and communicate with each other. Okay, hey, we saw this face at this camera. Hey, now we see this face at this camera. So, yeah. Yes.
What do your transport and application protocols look like? More specifically, how are the Raspberry Pis and the vibration sensors communicating to the Mac Mini?
Yeah, that's a great question. Yeah. So really just posts. So
HTTP?
Yeah, HTTP
Okay.
post requests. Yeah. For simple CRUD.
REST API?
Yeah. We didn't need anything too fancy.
Sure. I just didn't know if you were using sockets for real time or
No.
just, yeah, okay. Makes sense.
Gets the job done. Any other questions?
Thank you very much.
All right. That's good.
What do we want to get started? All right, next we have, oh, where the order went. Sorry, it's all out of order here. No, but you're, oh, my. All right. So next up, we have Caden Miller and his project, the UU Student, a new Union University student app. So everybody welcome Caden.
Thank you very much. As you said, my name is Caden Miller. My decision for a senior project was to revamp the Union Student app. A while back, they used to have a model, I think during my freshman year, that was an actual Union Student app. It felt unique to the school. Now I feel like we have something that is very sterile, copy-paste, and to my knowledge, something we kind of just paid for as an in-between for an actual student app. So I determined to take it upon myself and build a new one. The main goals I had was to make it more user-friendly because it's kind of a pain to go through and look at. Everything feels overly organized to the point where you can't find anything. So I wanted to make it more intuitive, make it substantially simpler and easier for people to just find things that they need. Apologies. I wanted to make it less organized without losing any feeling of organization to it. And I wanted to make it feel less like a hospital waiting room. So I set out to do that. My resources were VS Code, which is what I coded everything in. Balsamic I used for a class I had with Dr. Glass to kind of design a lot of the UI functions. Stack Overflow, because that thing is a godsend. It helps me not have code break. Knowledge provided by the professors here, being Tacker, Talbot, who is sadly no longer with us. He's not dead. Glass and Professor Tracy. And Claude AI, because despite my avid hate for it, it has helped out a lot, because I am not really a good coder. This stuff does not come naturally to me, so it helped explain a lot of processes so that I could build something that functions. The languages that I used were primarily Kotlin. When I was researching what I wanted to use to build it, it came out to be between Kotlin and a thing called Swift. And ultimately it was kind of a coin toss, but for those unfamiliar with Kotlin, it's very similar to Python. And again, not being super great at coding, I couldn't really find any major dissimilarities between the two. So just think of it as mobile app Python, CSS and HTML for UI and padding and all of that fun stuff. Now I have the demo, so you can just set it up. That's okay. I do apologize in advance. It's not going to be super big because it is designed for a mobile device, so it's kind of stuck to this little mobile screen, and any adjustment kind of screws up the layout. So. Let's do that.
Yes. Your note's missing the U.
I don't know what you're talking about, Sam. Show us. The actual login takes a little bit, but everything else works fairly smoothly because it's not a really beefy thing. It's more or less just a UI that I built. But this is the main premise of this is the main screen, as you can tell, and to me, at least, everything feels very overt about what it is holding. So we have the news, which, if I click on it correctly, breaks up all the things that kind of go on Union's campus. And another part of this that I wanted to do was I wanted to make it easier to integrate Greek life with everything. So admittedly, I did not run any of this by Greek life. I just threw it in there. But my goal for this was to have a way for the average student to connect with things that they're not aware of going on in campus. So this would be things that ATO is doing, or IO, or whatever the Greek life sex. Just so everything feels less segregated, and I don't know, there seems to be like stereotypes about Greek life that the average student has, and I kind of wanted to break that down a bit by integrating them into average campus life. I have maps, which part of the grammar. What this is supposed to do is to help new students and people who get lost like me for surrounding areas, and I don't have any of this loaded in. It was kind of a crunch when it came down to actually finishing it, but map of the campus, which we all typically get during Welcome Week, it was supposed to have that in here, a surrounding area, so you can leave campus and actually find things without getting lost in downtown Jackson and the absurdity of Van Drive. And a map of Union Woods, because going outside is good for you. The buildings is supposed to have basically where all of the professors and faculties are within the actual building, so that you don't have to go through the website and try to figure out how to find all of your professors. Instead, it would just be natively on your phone. And making meetings with your professor would be a bit easier. Weather. Paw print, because this is kind of an annoying thing to do through the website. I wanted to try to make it where it would be, again, on the app, and you can just choose to make a print and immediately go to the actual make a print section of paw print. Your ID card. This is my dog. Feel free to scan the QR code. This is just your ID card that you already have, but I put it on there because it's nice to have. Self-service and my account are the self-service and my account sex of your student account. And again, like I said before, and I've said several times, main goal of this is to integrate everything onto your phone, specifically in the app, so you don't have to use a browser and can just find everything without some weird delay or your search engine deciding that the Union website is illegal for some reason. I tend to have that problem and can't actually use a lot of the features that the Union website provides, so this was to help alleviate that. Services is all of the additional services that Union offers. post office or disability services. This is just, again, streamline things, make it easier on the student to just make appointments or find out where things are without having to use their brain, I guess. Safety and security, this is supposed to be an easy way to contact them so that you can alert them if things are going on, or if you don't feel safe in the near area, that you can call them, let them come help you. Or if something's broken and you need it fixed, you can address it with them as well. Dining options, my goal for this was to have it to where the menus for each would be in the app, so you don't have to trek all the way to Kobo, the whole 5-minute walk that it is, to figure out if you actually wanted to eat there or not. Yep. I wasn't entirely sure what to do with the settings page, but I know that our app has one, so I kind of just threw it on there. And that, for the most part, is the demo of the project. So I'll close that out. What I learned. Learned how to structure code, which is, again, something I really struggled with early on. This forced me to fix the way my code looks, make it look clean so I can actually figure out if something is wrong, where it is wrong, and then just address that singular problem without breaking everything else. I use online resources. I kind of already knew how to do that, but not specifically for coding. And this allowed me to discover things like Stack Overflow and Indian YouTubers who know way more than anybody else will. So it was an excellent resource and an excellent way to find new resources so that I could, again, present a project that I would be proud of. Patience, because coding is incredibly frustrating. And a lot of times you're not going to know what's wrong for no reason because you're getting so adamant and frustrated with the actual code itself that it's just something simple like a missing semicolon, which totally didn't happen several times. Digital design, like I said, I had a class with Dr. Glass where I learned all of this, and all of the UI things that you saw I designed and implemented myself. And failure. That failure is okay. It's something you can learn from. Often is very helpful in preventing further and greater failure down the line. Be grateful for failure now. Because the small things are better to mess up than the entire project. Before I go to my last slide, I wanted to show you all the code that I have. This is just a simple run thing that just, it grabs, lost it. Well, it grabs this, which is a Gradle system. This is a smaller, bite-sized version of the majority of the code that I have that allows it to see everything, implement it the way that it wants that you want it to be implemented. It runs it without having to run each individual page or without things not having dependencies or the plugins. This just lets me, I'm really blanking on this, I apologize. Yeah, the Gradle system condenses everything, puts it into one small space to where I can make minor adjustments without affecting the large amount of my code. It then takes all of that, pushes it to the run system to where I can just run the Gradle, and then the Gradle does a lot of the heavy lifting for me. This is a sample. This is the homepage. I had Claude help me with a bit of the, not the syntax, but the comments, because I do not know how to comment code to save my life. So, this is all of the background and foreground for the main homepage that you saw. And I got something. And yeah, that's my senior project. Questions, comments, and smart aleck remarks. Yes, Eston.
So what would you say, get a big one thing, what would you say is the primary advantage for app over our current?
Right now, there isn't really one. because for the most part, I didn't have a whole lot of time to actually build it and make it a fully functioning app. This is kind of just a developed UI function. So right now, there isn't one. What I hope in the future, if Union decides to take it and run with it, or ignore it completely, is to have it to where everything takes less time on its current app, because for some reason, everything is just a link to the website as opposed to having it be natively on the app. My hope is to have a lot of the functions just be on the app, so you're not frustrated with your search engine.
You said earlier in the presentation that when you were using the app, you got into like a situation where you found where it said like we're doing something that was like quote unquote illegal. I'm kind of wondering how will this app like quote unquote like fix the problem that you were having, or maybe I misheard what you said there.
I don't recall doing anything illegal or having anything illegal done on my app.
But I'm assuming you meant like an error happened in the app.
I'm not sure what your question is addressing.
I believe this is in reference to your statement that search engines find Union's website illegal.
Oh, that. Okay, so for some reason, anytime I try using my Mac to access Union's website, it does not load regardless of the search engine I use. So I don't know if that's a me problem or a search engine problem, because I've used my other devices and used an alternative search engine to Brave, because that one has a lot of problems with it for some reason, and it works. So I don't really know. I think it's kind of just a personal issue. I'm sorry, that I can't fully address your question.
It sounds like that this project was a very large learning experience to you.
Yes.
Having known what you do now about your project, if you had the opportunity to restart, what are some things that you think you would do differently?
I wouldn't do it because I learned that I don't like to code.
Fair enough.
Things that I would do differently, not be mad at myself when things don't work.
It's a really hard skill to learn.
Yeah,
It really
because
is.
a lot of the time it's not my intentional fault, it's just fat fingering keys.
Yeah.
And I just don't notice it at
Yeah.
the time or even later. So, like the lessons learned bit, just patience with myself.
Yeah.
All right, thank you very much.
Thank you.
What are you doing here? How are we there? I'm not giving you another problem. That's the only thing I have.
Well, no, I want you to.
I came in your body.
Well, we need to probably switch. Or-
Oh, yeah, I know.
On one hand, helpful with that, and sometimes 15
Yeah.
sometimes 5 minutes, not 0. And we
Yeah.
know what's going on with technology.
Thanks. So I guess this is going to start my presentation. So,
Yes. Wireless. Okay.
Hey, friend. How are you?
I'm doing well.
Didn't see you.
Been like a year, right?
Something like that. Are you on the clock?
Well, this is his job. He's being paid for this.
You should. You're doing recon for future.
He plugged in his right?
You'll see what we're up to. Yeah, this is or engineering. Probably should have started. The room's not too bad.
yeah.
You just gotta get around it. You gotta get through People take certain routes on the
All right, so our next presenter is Alex Keene, and he's presenting his project Smart Lift, a computer vision approach to powerlifting form analysis. So let's give it up for Alex.
Hey everyone, like Professor Glass said, my name is Alex Keene, and here's my senior project, Smart Lift. Now, before I even get started with the PowerPoint, I think it's a good idea just to give a little bit of background behind this project. So, for those of you guys who don't know, there's been a big push in the gym community lately on what we call science-based lifting. Now, this is a little bit different than in previous generations of lifters who mostly just went to the gym and sought to lift as heavy as possible, even if it came at the cost of good technique. However, nowadays, an increased emphasis has been placed on lifting safely using correct form, and it looks like that's always fun. Should I just do HDMI, you think? I'll give it one more shot. Okay, we're back. So yeah, like I was saying, there's been a big push lately in the gym community on science-based lifting, which is a little bit different than in previous generations who mostly just went to the gym and lifted as heavy as possible. because nowadays an increased emphasis has been placed on lifting safely using correct form, stuff like this. Now, intermediate or advanced lifters typically know the difference between good and bad form, but this is not always the case for beginners. So my goal was to create a model. Now my laptop is black screen. Not my fault, guys.
These computer things.
On the wire.
I think I'm going to. It's restarting for some reason.
Oh. Really made it.
Yeah. I knew that was a risky game right there. I was playing, trying to screen cast.
Android phone.
It breaks.
Yes, that's why I noticed it immediately. It's like, my handbrake.
Classic.
Yep. I thought that did.
And they promised us that they were going to stop doing it. It hasn't stopped.
Well, it worked so good last night. I was like, all right, I'm just going to go with it. All right. Once again, here we are. So I'll begin quickly by going over some of the math that you guys need to know to even understand the project, along with how I collected my data. And then after that, I'll explain how I created my model using the data that I collected. And then after that, I'll present a few areas of further research and then conclude with the demonstration. So before we even get started with anything else, I want to give a brief little math review that some of you, or that you guys will need to know to even understand the project at all. So for all of you guys, hopefully remember how plotting points on a coordinate plane works. So here we have our, here on this graph, we have the point 1, 2, which is our x, y. However, when we go to 3 dimensions, we now have an x, y, and a z coordinate. And for example, here I have the point 1, 2, 3 plotted. Next, I want to show how I analyze my data. So I used a framework called MediaPipe, which is basically just a pose detection framework that uses computer vision. So MediaPipe has 33 built-in landmarks, each of which has an x, y, and z coordinate. Now, in this project, we really only care about joint angles, and so for our purposes, there are a few angles that we need to consider. So here we need to know the angle of the shoulders, the elbows, the hips, and the knees. And if we know these, it'll give us a decent idea of the technique behind each lift. Now, I do want to go into a little bit of detail into the data collection process because that was honestly probably the longest part of this project. So I went to YouTube and searched for hours to find good videos for my training data set for squats, bench presses, and deadlifts. And each of these videos is ran through MediaPipe, and the angle of each joint that we saw from the previous slide is stored at every frame, or 60 times per second. And then we can store these in an NPZ file, which is good for storing multidimensional arrays like we have here. And I have a little overview of what the file structure might look like over here on the right. So this is the video on the right, deadlift 1, which is one of the videos that my model was trained on. And here I have the left hip plotted over time, which you can see in the plot title. And you can sort of see it oscillating up and down with each repetition. On top of that, I also stored the X, Y, and Z coordinate of the 33 different landmarks at each frame as well. And I give a little bit of an example of what this looks like here. So as you can tell right off the bat, there's a ton of data here. And just to put it into context, we have 33 landmarks, which each have an X, Y, and a Z coordinate attached to them, along with 8 joint angles, or 107 total data points stored at every frame, which means that for every second of video footage analyzed, we have 6,420 data points stored. So there are just millions over the course of this entire project, as you can imagine. So I definitely do have a lot of data to work with here. And anyway, if you look over here on the right, you can see an example of what this looks like. So here we have the X, Y, and Z coordinate for the nose in deadlift 1. And you can sort of see when each rep happens with each one oscillating up and down. Before I move on, I do want you guys to look here at the Z coordinate, which is in green. So the Z coordinate here is our depth coordinate. And as you can kind of notice right away, it's pretty inaccurate. As you can see down here, it's kind of shaky. As you can probably imagine, that'll lead us to some inaccuracies later on. And I'll touch on that a little bit later. Now, instead of just explaining what it does, I figured it'd be a good idea just to show you guys live. So here is professional powerlifter Jared Feather doing some deadlifts. And so we can notice here that each of his joint angles are stored and plotted over here on the right, and that there are some pretty unsurprising results. So for example, here we can notice that the elbow joint stays locked at 180 degrees throughout the entire deadlift, which makes sense if you just look at him. We can also see all the other joints sort of oscillating up and down in a uniform way, which we can use later on to make calculations on the data. However, you can start to see some of the failures of the model already. Because our Z coordinate isn't super accurate, like I said in the last slide, our angles aren't super accurate as well. So for example, here his left shoulder is consistently about 10 degrees higher than his right shoulder, even though in all reality they're at the same angle. So as you can imagine, that will prove difficult later when we try to analyze this. Now let's dive into the actual model that I made. So the initial question that I had was whether it was possible or not to determine good lifting technique from just a video alone. And my goal was to create a statistical model using the data that I collected to make predictions on this. Now, the methodology and the math behind this is a little bit outside the scope of this project, but if you want to know more, feel free to ask me. I can show you some time. So anyway, to start the data processing, I made a custom rep detection algorithm, which I was actually pretty proud of. So we can notice here that if we take the joint data from an example like in the previous slide, we can isolate each repetition so that we can process them individually. And that's because each repetition, even within the same video, is not always the same. So for example here, I have the squat knee joint on a, I believe that's, I can't read it from here. But anyway, basically, you can see each of his repetitions, and that they're not the same even within the same video. So for example, on the first rep, it looks like his squat only got down to about 85 degrees. But on the third rep, it looks like it gets down to even 75 degrees. So even within the same video, the lift is not always the same. So it's a good idea to process each repetition individually. So after we have all of our data, we can create a model with it. And for example's sake here, I have all of the knee joint data from my squat recordings overlaid on top of each other. Now we do have some obvious patterns here. You can already start to see some of the weaknesses of the model. First off, the data has extremely high variability. I mean, it looks like it ranges from 60 to 100 degrees, and ideally we would want way less of a range than that. And obviously that'll come back to bite us later. But anyway, if we assume that these joint angles are normally distributed and independent, we can create a credible and prediction interval for each frame. And if we show that here, we can see our expected mean, the credible interval of that mean, and the predicted interval. Now, don't worry too much if you don't really understand what each of this means. Basically, you just want to be in the green region whenever you're doing a repetition. And the purple region there is what an ideal squat would look like. And then also real quick, I do want to point out that the green region is a lot wider than we would hope, and that's simply just because we have really high variability in our data. There's not much. Now this is obviously just one joint, and there are many others within this project, but just for time's sake, I'm just going to leave it here. You guys get the gist. So next I want to dive into some of the results of the model. So first I have a quote here by British statistician George Box, which is quite a famous quote. It says that all models are wrong, but some are useful. And as it turns out, mine is not only wrong, but is also not very useful. And now this is due to a variety of reasons. So first of all, MediaPipe absolutely hates having multiple people in frame, and it causes it to mess up pretty terribly. So any video with multiple people in it is immediately pretty much useless, which rules out quite a bit of YouTube videos that I wanted to use to train my data, as you can imagine. Also, even for the best videos, there's only so much you can do with a two-dimensional video when you want three-dimensional data. I mean, even MediaPipe, which is maintained by Google and is basically top-notch when it comes to this stuff, just isn't super great at it. And on top of that, I was working with a limited data set just for reasons I spoke about earlier. It's hard to find good data for this. Now, finally, I do have some areas of future research that could be explored. First of all, I think that a different approach, like for example, a machine learning model, would probably be better here than a statistical model. I just didn't have the know-how to really implement that at the time. Also, I think it would really be interesting to try to determine how much variation actually exists among elite lifters. Because obviously when we trained our model, we saw a lot, but I think it'd be interesting to find if that was due to actual variation or just problems with the recording. And finally, if we were to repeat this experiment in like a controlled lab, where we hooked up like sensors to the different joints and like really accurately measured, would we get anything different? And so finally, I do want to do a demonstration, and because my computer crashed, it might not be super great because I'll have to restart the kernel, but we'll see how it works. I tried to do this in the room earlier and it worked just fine, so fingers crossed it'll work again. It might take a second to run because again. Okay, yeah, here we are. As you can see, I'm not much of a UX guy, but it gets the job done. So the only one of these that you can really do without any equipment is the squat. So I'm just going to do that. As you can sort of see, if I can get my full body in frame. It'll sort of snap onto me, and it won't actually start tracking until the rep begins. So if I just get in position like I'm about to do a squat, go through with it, and then hit stop. It should only pick up the actual repetition that I did, and then we can sort of see how it stands up to my model. Okay, yeah, here we go. This actually doesn't look bad. So we can see here the green regions that I was talking about earlier, and the blue line is my repetition. You can see my elbows and knees sort of fall in the green region like we would expect. But as you can see here, a big problem with the squat recordings is that the hip measurement is not accurate whatsoever. So you can see that my left hip is like consistently way higher than my right hip, even though in all reality, I mean, you guys saw me there at the same angle. And the shoulders don't really matter for a squat. But you guys can start to see that like this just isn't going to be super duper accurate with a technology such as this. We'd have to get something more accurate. But did the best of what I could. Yeah, that concludes the demonstration. So any questions? Professor Glass.
So out of curiosity, and it may be just time, I don't know if anybody's tried it, but can you potentially define an algorithm for the angle of the video in terms of like, because your left hip was potentially closer than your right, so that may cause the angle measurement to be wrong because it's trying to deal with a 2D plane, but could you potentially determine the angle that the subject's at and then be able to have an algorithm to adjust or normalize the closer versus the farther?
There were a few things that I tried. So I tried a whole bunch of things to try to fix that because that was the biggest problem. The best solution that I honestly came up with was just, if you're doing a repetition, the model should ideally only pick up the side that it's facing. So like, I was facing this way, so the model would only pick up the left side and just completely throw out the right side just because it's way more inaccurate. If you were to have cameras facing from your left and your right, and like maybe behind you as well, and sort of use all that data in conjunction to make a prediction, you'd probably get something way more accurate. But like I said, the scope of this project was for beginner lifters who just want to be able to whip out their phone and get an instant result. And for that purpose, I mean, having multiple cameras and setup is not really what I was looking for.
Yeah, I'd be fascinated to see if the data, like you mentioned, does the data get any better if you have just the phone camera, or if you had a three-dimensional depth camera like Microsoft played with Kinect, or you had a whole room camera like some of the VR systems. Like, could you even get to a point?
Yeah. Well, like I said, I think I remember talking to you about potentially investing in a depth camera, but that sort of, like I said, defeats the scope of this project. Was for beginner lifters just to be in the gym without their phone, that sort of thing. But I think it would be interesting.
The interesting thing you might be able to try that shortcuts the need for multiple cameras is multiple mirrors on a single camera, to where if you could see the left side and then reflect to see the right side and then crop the video in such a way that you get essentially two video feeds from one camera. It's like,
I'm not sure with that.
Yeah, it's still unrealistic to expect a beginner to set up, but I think you could still get around needing a second camera if you use the mirror the right way.
I mean, there's definitely a lot of avenues you could explore with something like this. I just kind of got the basic thing out of the way, and you could expand it from there. Yeah. Anybody else?
All right. Thank you so much. Yeah, the last thing we need to do is encourage people in the gym to bring more phones to set up around.
Much more tape.
I was going to tell you.
That crashing threw me off so bad.
Yeah.
Oh yeah, my computer like black screen. It was like Windows ran into a problem and he it's just, yeah.
Honestly, I think
And then each one independently. Thank you.
Actually, you really could be on. Not gonna lie.
I mean, you've got.
Four.
Facing.
Yeah, I was gonna go to Eli Times.
I like those are yours.
Yes, they are.
You can try to ask. You also want to try to.
In class, I love Windows with all the players. Yeah, because all this in those rooms of flies. Yes. All these. Everybody, look at like it's easy to assume. But then also, it's all opinions.
we're good, you know.
Yeah, no. Yeah. I remember. Yeah, I just went to. It's got shitty stuff. Or like it's electronically, like basically a system.
Yeah, it's a good game.
My probably cost more than what the building costs.
That is awesome. Why does it?
That is such a weird escape.
Yeah.
If I cast.
That is GPU artifact.
That's a really strange setup. I agree. On the scaling.
Yeah.
Yes.
Yeah.
Rather than the screen here.
Yes.
It's similar to like how they do the map.
Yeah.
I think the map is the map.
Yes, so, yeah, this is what I was talking the other thing. Yeah, you wire things that you have to do. You ready? All right, we're gonna get started on the next one. After this session, if y'all need a drink or you want a snack, they're set up and available outside the door. So this session is Stephen Caruvana, and he is presenting his project, The Interactive Map of Union's Campus. So let's give it up for Stephen.
So as you said, my name is Stephen Caruvana, and my project is to make an app of Union's Campus. So this is like a preview of what the map looks like. I just wanted to be able to select buildings or places on campus and get information about them, see a picture. I'd like to be able to, in the
in the future add a search function to be able to maybe look up buildings or find professors' offices or like where the disc golf course is. But I'm not to that point yet. But right now you can select different places and get information about them. For this project, I used React Native, and I've never done any app development, web development before, so this was all really new to me, and it took a lot of time to learn all of this. React Native is really nice. It can deploy to Android, iOS, or the web because it uses JavaScript and TypeScript, and then basically like transfers that into whatever the app code would be for iOS or Android. And so it just simplifies it a lot into like its own language that deploys everywhere. And I used Expo with React Native. So Expo is essentially a platform to run an app off of that's coded with React Native. So Expo actually has their own map system, but I ran into some issues with it because for some reason Expo Maps doesn't work well with their app that you use to run their apps, which is really weird. So I just ended up using React Native's map library, and it worked well. I used Google Map APIs, which I've also never done anything with APIs before, so that was all new to me. I had to like make an account, figure out how to use APIs, figure out how to make it secure so that like it couldn't just get skimmed and spammed. I charge money, and so that was all really new to me. I'm gonna go to app now. There we go. Okay. So this is the app right now. It's just Union's campus, and I have all of these different areas and buildings, and it has information about them and a picture. And in what I'm working on right now is making it so like you can see that it doesn't show like the chapel or like specific areas in the PAC, and I'd like to do that. But if I had all of that information when it's zoomed out like this, it would be way too cluttered. It's even cluttered right now. So I'm working on making it so when you tap on it, it then comes up with more information once it zooms in about different spots. Maybe I'll try and like highlight hallways, label them so people could see where in the building they need to get to. One thing that was very annoying with this, with doing this, is you see these labels, the red labels for all the buildings. React Native Maps, for some reason, the function that you use to create these labels, if it goes, I think it's past 38 of the units of size, if you go past that, it just cuts it off. And so that's why it's so small and you might be having trouble reading it, is because I can't go bigger and I haven't found a solution for that yet. So it is a bit frustrating. For some reason, it just, before it looks at the size of like the text you have in it, it just decides how big it needs to be. And it just skips the process of looking at it. And so the only solution I found was some random person on forums like coded a fix to it. And I didn't really feel like trying to use that. So that was fun. But for the future, hopefully you'll be able to like select the quads and then it'll show information about all the different names of the quads, and you'll be able to select freshman dorms and it'll show information about them. But for now, it's fairly limited, and like the disc golf course, it would be very neat to be able to show all the different holes and where they go. Alright. There we go. So that's an example of the clipping that happened. It just cuts it off. It's really interesting. One thing I learned from all this, documentation is a maze and it can be very hard to learn from. And YouTubers who decided to make a video series about React Native Expo, very nice. They have very few views, but it was very helpful. Let's see. I think that's all I have. Questions?
So Google Maps was your base map. Did you have any problems with anything not being on the map? It's Google doesn't like to take pictures of us too long.
I didn't really have any problems with that. I had some problems with, like, when I was trying to use the Expo version of the maps, I was also having issues with just getting the APIs to connect, which was kind of annoying, but I've never worked with APIs before, so I don't have a ton of knowledge of the APIs, but Google actually has very in-depth, like, customizability for their APIs, and they have a lot of different APIs. So I can choose what kind of overlay I want. I can choose if I want their pop-ups to be shown in my app. It is very nice. But I didn't really have any issues with it not showing stuff, although the Ethos forum isn't on Google Maps yet, and the BAC is still there. So it's not as up to date as it could be if I like somehow got like a drone shot of campus or like tried to like draw my own campus of map, create my own map of campus. But for the most part, it was pretty nice. It was pretty simple, very efficient to use.
Do you have an idea of the frequency that they update? Sorry, question.
They never even did the groundbreaking for Ethos 4, and that's at least 3 years.
It's been at least 3.
It's been at
Yeah.
least 3 years. We can't control it.
Yeah, it'd be nice though. Good to see it. Yes.
Have you thought about expanding to show the Union Woods, like the trails? Because I don't think that would be too difficult, because I may or may not have done a project on that. And it is on the website, I think. But that could be another cool thing to show
Yeah.
for a future state.
I had not thought of that, but that would be something that would be, I don't think that would be too hard to do, to just expand it up there and then like try and highlight the, gosh, I'll probably try and do that, honestly. Yeah,
Yep.
that's a good idea.
All right. Well, thank you so much. All right, so we have a few minutes to the next presenter, so if y'all want to, it's a great time if y'all need a snack, some water or something, we can do that.
Sophomore year, I had a project called the Union Map.
I'm having issues as well. My entire computer just froze. It's very odd.
Ask first. It might be. For some reason.
Every single play plan, it would be tired of it.
Just continuing on what happened. So start, we're gonna go over the overview. So for my overview, I have 3 questions I asked myself, which was question number 1, what was this project made in and what scripts did I use? Question 2, why was this project made? And question 3, what were my inspirations behind this project? So we're gonna start with question 1, which is why was it made, or what was it made in and what I used. So I used an engine called Godot. Godot uses GD scripts and a hint of C# and C++. With the new update though, the last 2 right there are usually not really needed anymore. They kind of just implemented them in the GD script, and now you just have to use that. The second question, why was it made? I made this project so I could challenge myself in an artistic manner while also focusing on my field of study, which centers on research, basically. We'll move on to the third question, which is, what were my inspirations behind this project? So the inspiration behind it were indie game developers like Eric Barron and Team Cherry, which are small developers who made it big by just implementing their ideas, hoping it all the stutter, my bad. So we're just going to get into the tech of my game. So we're going to start out with scenes. The scenes of the Godot are basically like movie. When you direct a movie, you take multiple scenes, you put them all together. That's kind of how Godot works. It's not just like game scenes; it's more like objects, stuff like that as well. So moving on to the scene structure. So there are a bunch of arrows pointing inward. So right here is a collision shape. Basically, that is just an area where I have I've made it. This one's a border. So if because the player also has a collision shape around it, if these 2 come together, they cannot collide. So they're just going to not go through each other. For the character design himself, he sees the collision shape. I had to use animation frames, which are multiple frames of the character, and I had to not loop them so they wouldn't continually animate over time. And then I had to give the player a sword hitbox to where at the end, where it has a weak point on one of the bosses from my games, that sword would be able to hit the boss to take deal damage. Moving on to the character movement, I had to go to the project settings, which is Godot's own part of the engine. There's no scripts involved. You had to go through and you had to define certain buttons on your keyboard. In this case, I chose A, W, A, S, D. And then I had to basically input those keys to make movement. And then we're going to go into sound. For sound, I had to record and download MP3 files for each of my recordings and implement them into Godot. And I have them set for different scenes throughout Godot to where whatever that scene plays, that music will play as well. Then we're getting into the research side of my project. So I used Polyhaven, Pixel Art, Piskel, and Blender to help create some of the designs inside my game. And the research behind it was Bracky's YouTube channel, which also has a private website that's free, that has free Godot tutorials in it. Godot Guru, YouTube, and then Professor Glass himself to help out with some of the design. Some of his classes help a lot. Some of the lessons and advice that I have. We'll start with the lessons. So a major lesson that I learned was you don't always have to be perfect on the first try. So I had a problem with this that I went to Professor Glass about. And I was like, it sucks. It's not looking too good. And he was like, it's okay. It does not need to be perfect. I was like, thank you. And for some reason that hit. And so yeah, you don't have to be perfect on your first try. And sometimes just getting something out there allows you to get a step up, to get more ego at what you want to do. And for the advice, I would say that I would provide today, sometimes we rush so much that we make mistakes instead of enjoying the time we take to work on a project we enjoy. That's one problem that I had was like I kept rushing and rushing, and I was like, I gotta get this done. And sometimes I just didn't enjoy some parts of it. But when I took some time to just like say a couple hours a day, I started enjoying it more after last semester. I do have for the future. I would provide better artwork, better game elements in my game, also some NPCs to provide some AI to walk around, and then hopefully one day I'd be able to post it and get it out there in the world. So I'm going to go ahead and demo my game. Hopefully this doesn't break me. Maybe help to do this part. I'll do this part. I'm not gonna lie.
Are you waiting for Godot?
No, I'm waiting for just like Godot's already it's running. Show the demo of my game. So this is the main screen. These also have collisions on them to where start. So the main menu. So these start and exit game both have collisions behind them. Where I put it where the mouse hovers over, they'll have a hover action, and if I click it, it'll put us into the game. So there is sound, but I'm not going to set all that up since it took me too long to get over here. Basically, you can move around with the character. This is the animation of walking, and if I push A, it should flip the character over. And if I jump, it should have a jump animation. And when I click, it should also fight as well, showing that he fights. Another thing I want to show is one
when I get to the end here, there is a building, and I had put another collision in the doorway that acts like a door. So right here, and I made it to where the E key, when you push E, it's into another scene. So that would be this scene. And while we're in here, we can jump on platforms and even go through the same platforms. We get to the next scene. Because I'm short on time, I'm gonna go ahead and skip out of this.
You're fine on time.
So one thing I want to show is when I get to a building like this. So one problem I had was when I go into a building and I leave the building, it would send me back to the start of that scene that I was just in. So I had to make a whole other scene where I place the character outside of the building. So it would do that every single time. And there is audio. Obviously you can't hear it right now, but each building and each like scene like this one has a different audio to it. So when I go to this building, I go over here to the bar or the soda shop. I push E again, and we can just flip through all the options that we can choose from, and we can go back as well. And we will push buy. We can purchase the item. It's not in inventory yet. I don't have all that set up, sadly. And so we can get out of here, and we can go to the so long. I should not have made this as long as I did, but basically what we do is we get to the boss right here. We push him to the sign, and we get into boss battle. It's a lot bigger than this, but to save time, I just put us all the way at the top. And right here is the weak points. Where we go over here, we hit it. It should blink, saying that we took the deal damage. And after the fourth hit, I added a new feature since last semester, to where instead of it just disappearing, it'll take us to a whole new part of the game that took a while to get together. And it should bring us to a 3D world. Right now the camera's really weird, but this is what Polyhaven allows me to do. It allows us to create a sky. I can't look up right now, which is why it's all like wonky. And it allows me to add shaders, and then Knoell has their own way of creating water. So there's like a water movement that allows you, no physics yet, but you can walk into it and look around as all wonky and stuff. I think that's all I have. So, any questions?
Where are you going to put it in 3D world?
For the 3D world, I was going to basically give the character, so at the end of the game, I don't have anything to do, obviously you have no choice, but I was going to add either to continue in 2D or replay the same level in 3D. So you go through the exact same level with new features, new elements, all in 3D.
So was the pixel art, were those assets related to the Godot engine, or did you?
Those from, so all the art in this game, except for the 3D one, was personally made by me in pixel art. So it was a painstaking process. That's why I was saying like, oh, I'm not perfect and all that stuff.
It looks great. It looks great.
Yeah. So yeah, a lot of it, and I had to. So there's another one that I had in my slides where it was not pixel art; it was a different pixel like platform. So pixel art, the one I used, would not allow me to implement the picture, like the animated pictures, over into Godot without like making it a whole other image, like 5 images. So I had to use a whole other like pixel art image or software to basically make it frame by frame. It's like Godot, and I went through. You have to cut them up basically. If I go to the player right here. Godot crash, but basically you would go to player and then it would show frame by frame, and I was able to choose different like actions for each frame. So the fight frame would be him throwing the sword, walking would be him shifting his feet around. So it'd be frame by frame basically. Any more questions?
All right, good job. I think you win the award for the most tech challenge.
I always have the tech problem, I'm not gonna lie. Just never fails.
Yeah.
Alright, hopefully mine doesn't crash. Let's see. I don't think it should.
Always the challenge. We can say, hey, practice, but check it beforehand, and then it will still behave differently.
have a long line reached about here. I was about to.
Yeah.
Very interesting presentation.
That's fine.
We can wait.
For a second.
Wait while I train the next wave of incident response experts.
Anticipation.
Yes.
Y'all can remember, please fill out the evaluation forms for each speaker, as many as you, or not as many as you can. This is just vote one per speaker, but many different speakers.
Can I fill out one for myself?
I mean, you can. I can't tell you it'll be counted.
Bennett Wilson.
You can fill it out. It's funny, time flies if you're trying to fix the tech problem. And then when you have a tech problem, it flies. Just
Stare at me the whole time. Okay.
The template.
I was trying to get the designer to make something look. I was like, incident response plan. It gave me like a notepad. And I was like, but eventually they got.
Those are always an interesting challenge, but really hit and miss to whether or not they have half an idea what you're looking
They're always nice co-pilot to make.
Could.
Well,
You may not want to, but you could.
You always ask, they don't.
Oh, yeah, oh, no, it absolutely wants to be part of your work. It's desperate to be part of your workflow. All right, so our next speaker is Bennett Wilson, and he's going to present his project, the Incident Response Plan Builder. So let's give it up for Bennett.
Yes, as Professor Glass mentioned, I'm Bennett Wilson. My project is all about incident response plans. That's its own little sector of cybersecurity. People build their entire careers around this. And let's get into it. So, general idea, I wanted to build a risk management heavy approach to incident response. And I took frameworks such as SANS, which stands for Sysadmin, Audit, Network, and Security, and NIST, which is the National Institute of Standards and Technology. I took their incident response frameworks and I wanted to say, these are broad. Let's put risk management on top of it to prioritize what's most important first. Because if you're like me and you're in cybersecurity, you know a lot of bad things can happen, but you also want prioritization. You want to prioritize protecting what's most important first. So another thing I wanted to do is I wanted to build a template for incident response planning, and I wanted to promote incident response awareness. You can think of this presentation as that in a way. But I diagrammed out my entire project according to the SANS life cycle, and they boil it down to 6 steps, and that's preparation, identification, containment, eradication, recovery, and lessons learned. Now, when you think incident response plan, if you're like me, you think of preparation. You might not think of containment or eradication immediately, but that doesn't mean that you shouldn't prepare for how you're going to contain and how you're going to eradicate something. So what I'm trying to show in this diagram is, let's prepare at the organizational level, which is its own thing. Let's also prepare for how we're going to identify. Let's prepare for how we're going to eradicate incidents. But you also want to cover the effectiveness between these things. So, for example, if your containment method is not effective in actually capturing the incident, your eradication method is going to fail. So if you have a defect that's in a test environment, your development environment, and your production environment, and you only eradicate it in production, then it's going to make its way back into production. So your containment methods need to be effective. And in my opinion, part of preparation is assessing that effectiveness, which you can do to a level. Obviously, there is going to be fails there, but we're trying to avoid those. And then research and technologies, as I said, we use SANS and NIST. I did tweak SANS by getting into more risk management terms. And really, my risk management methodology is based on NIST RMF, which stands for Risk Management Framework. Very well-known industry standard, but I tweaked it into what I like to call the Bennett version of it, because NIST can be a little bit intense. They're more government and regulatory focused. That doesn't apply to everyone. I tried to make something that more applies to everybody. And then use HTML, CSS, JavaScript, libraries, JS, PDF. This library I did not know about until I used it for this, but it's open source and it allows PDF generation entirely on the client side. We will get into why that's important from a security perspective. And then, of course, VS Code and Visio for diagramming, because with frameworks this complicated, diagrams are my friend. Let's get into the actual product. So really, I've got a bunch of research here. I'm not going to read this all. If you would like to read it, you can do that in the future. But let's get into the framework. And these questions, there's a lot to cover, but really what I'm trying to capture is, let's get an organization prepared for like general incident response that are affecting critical assets. And that's exactly where you need to start. You need to start with, have you performed your critical asset profile? Like, have you performed asset criticality profile? That's a better way to put it. And there's so many, if you're even a small organization, you have so much to protect. Your attack surface can be crazy. And as you make more revenue, as you grow as a company, your attack surface is going to increase. You might, if you're a bank, you might have more branches. You might have multiple headquarters, depending on the region that you're in. You want to know, okay, what am I wanting to protect? Because if you don't know what to protect, how are you protect anything? And that's kind of the start of cybersecurity in a way, but I think that's where you need to start with preparation. And then, have you defined risk thresholds? Do you have a risk management framework to say, hey, this is critical. This event is bad. This incident is really bad. Bob in whatever department clicked the phishing email and leaked the database password to the internet. That's bad. You need something that tells you that that's a critical incident and that things are about to burn. And then do you have SLAs in place? Because if I'm working at a service desk and I see a critical incident come across my desk, ideally there would be like, I'm required to address this within 15 minutes. Otherwise, it's going to be like, oh, well, this problem's way too big. I'm never going to address this. And that's another thing about this framework tries to cover. But I kind of, as I mentioned, have a little risk management methodology down here. Really, it's your likelihood times your impact. So if you know something is almost certain to happen and you know its impact is really high, then that tells you what you need to prepare for protecting. I guess I just realized that on 2 screens. But yeah, that's what I'm talking about. Just a basic scorecard that I carried in here. Looking at what's very high from a risk perspective. And then
getting into more preparation. Do you have documentation for handling security-related incidents? Hopefully organizations do this. They don't, I would have some questions. And that's part of the point of this framework. It's, hey, if you don't have documentation, maybe you should get on that. And then, do you have controls for communicating when something bad happens? What if your entire company only runs through Microsoft Teams for communicating? What happens when Microsoft Teams gets wiped out? How are you going to communicate anything? Is your entire company going to fail? Ideally not. Just that kind of thing. And this goes on and on and on, because there's so much to cover in incident response. But really, preparation boils down to, do you have the SLAs? Do you have the risk management framework? Do you know what your critical assets are? Are you at least prepared at a base level? And the last thing I want to touch on here is, are you training your employees for incident response? So if we take an example of, I work at a bank. So if a traditional bank teller sees a really big problem, are they trained enough to know, okay, I need to report this phishing email to phishing? Have you trained them to do that? Have you train them to report, hey, I think my account got breached? Do they know they need to tell IT that? Some people genuinely don't. And I think it's important to have kind of a security culture. That's something that I've learned in some of my classes. The more trained your people are on security, the better the outcome of this type of thing will be. And then we're getting into the, is your preparation scalable to how you're going to identify, how you're going to contain, how you're going to eradicate? And then there's all sorts of other steps to that. So if you look at identification, trying to answer the question, is your identification process effective? You have an IDS, an IPS, an SIEM. If you're not a security person, you can ask me what all those mean after this, because we like our acronyms. But are your detection systems effective? If you have an incident detection system, have you stress tested? Because what happens if something bad happens and you don't have an incident detection system anymore? How are you going to know what's going on? That's something that companies need to do. And that's trying to get to, have you tested it? Is your process effective? Are you verifying incidents? Because if you have an automated incident detection process and it says, this phishing email that went to Bob, for example, is a critical incident. Well, what if Bob didn't click the email? Then it's probably not critical, and your automation system had a mistake. So I think it's always important to have somebody verifying them. Are you meeting your SLAs? Do your employees know that they need to meet SLAs? Is it scalable to containment? How are you going to contain what you haven't properly identified? Pretty much what I'm asking there. Are you prioritizing your containment of incidents that are affecting what's most critical? And I hope y'all see how I've bridged risk management into all of this. It's interwoven into everything. But yeah, moving on. You have short-term containment plans, long-term containment plans, and I think it's difficult to do those, for the record, because I think it's extremely difficult to say, I know exactly what incident is going to happen and when. If you know that, that's impressive. And honestly, if you know that, then why is it not secure? Like, you got to know, hey, this is what we need to secure if I know this exact incident is going to happen and when. So sometimes that can be tricky, but you can have a general short-term containment plan. Like, I guess, if a computer gets a virus, you need to contain that machine. You need to unplug it, get it off the network, contain it, and isolate it. That's an example of short-term containment. So general stuff like that. Hopefully I'll get the point there. And then lastly, talking about scalability. Going back to what I said earlier, you're not going to be able to eradicate something effectively if your containment method is bad. If you haven't fully contained something, you're not going to be able to get rid of it, especially in terms of a computer virus or something like that.
So really eradication is, how are you going to do root cause analysis? Are you reporting on incidents that have been eradicated? Something tricky about cybersecurity is showing business value. You can use incident response to prove, hey, we've eradicated these incidents or we've mitigated these threats. And you can use a framework like this, depending on what metrics you want to show. That's a whole other conversation that I'm not going to get into. But also, how are you going to validate your eradication? If you just say, oh, there's this computer virus and I eradicated it, well, who's going to prove that? Like, you can't just say that. Anyone that's worked in business. And really, like, what's the process for that? In my opinion, eradication should have sign off. Make somebody sign off on it. If they sign off on it, they're going to make sure it's right. Because if it's not, well, you're in trouble. And then recovery. You have backups. You need backups on backups, especially databases, for example. Are those backups trusted? Are they tested? They verified? Once you recover something like a backup or recover something from some incident, are you still like letting unmitigated high-risk vulnerabilities just pass into the chain? You want to think about that. Because if you only fix one problem, you have another unmitigated high-risk vulnerability that a system has detected. Maybe think about whether or not you want to deploy that to a production environment. And then documentation, like in that last box, and then lessons learned. You can really transform crisis into organizational improvement here, at least as long as you still have an organization, depending on the incident. But are you conducting a review of what happened? Are you preserving forensic evidence? Are you setting up KPIs, KRIs, that kind of stuff? And then are you updating your training? And in my opinion, your lessons learned and reassessment go right back up the chain to your preparation. So that's kind of my framework at a base level. Then of course we have this template which likes to zoom out when I put it on a bigger screen. It's not good online. But somebody can go in here and download a template based on everything that I just said. They can throw it in Word, do what they would like. And then I also have an example of that filled out. This is probably 40 pages. If you want more details on that, I'm happy to give them to you later. I'm sorry, there's a bad glare. But yeah, lessons learned. A lot of lessons learned. IRPs handle really, really sensitive organizational data. That's partially why I'm using a library like JSPDF. I don't want their data. I don't want to manage that. I don't want to be responsible for securing it. I want them to be able to just take my template on their side, and their security of their data is their responsibility. And then obviously if I ever lock something behind that, like a paywall, then a transactional database would be the only thing I would need. But that's something cool that I learned. And then for a project of this scale, I wish I had a group. Peer review only gets me so far with it just being me, especially because I can't respect the peer review of everybody because I have all the context. It's my project. But it's kind of interesting. I really wish I had like a group to build a framework like this. And the next steps is I'd like a video explaining the about section on the web app. I'd like to put a template in Excel. And then eventually I think it'd be cool to have machine learning built on top of all this. Say, maybe a company, your preparation needs work here, here, and here. Machine learning is a little tricky with that, but I think it's possible. And my advice for the next class is really just pick something big that you don't know much about and don't give up. It'll be hard, but don't give up. And I think it's really valuable to pick something that can teach you something to bring to the tech industry. I know this, I talk about this stuff all the time at work, and maybe people think I'm a big nerd, but I know having a security mindset is super, super valuable no matter where you go and what position you have. That will be very valuable. But special thanks to each of you for being here. Thank you for professors and peer reviewers. You know who you are. And any questions?
So is this a website that the file is on?
Eventually, it will be deployed. I haven't deployed it yet. It was deployed at one point, but then I removed it because those of you who have seen me present this in the past, it looks quite different. I've done a lot of maintenance on it. The plan is to deploy it again after I get an Excel template in there, because I think it'd be useful for people to be able to fill out an incident response plan in Excel, because that, I know people do that, I just haven't caught to it yet. Any other questions?
Well, thank you very much. You were going deeper. It's just transmute transitions. It was really cool the first 5 times, and then we started to get tired.
Yeah.
Good. All right, so next we have Eston Yandell and his Anistis project. So everybody give it up for Eston.
Well, hi everyone, my name is Eston Yandell. This is in fact the Anistis project. I'm very happy with it. I've been working on it for a while. Your first question might be, what is Anistis? Well, it stands for the Automated NIST Auditing Software, and it's kind of cursed because it's 2 acronyms in one. NIST is also an acronym. It stands for the National Institute for Standards and Technology. Now, what we're specifically covering with the Anistis project is NIST specification 800-171, which means nothing to any of you. Basically, it's for non-federal, non-confidential, but protected information. So whenever you send an email, whenever you email a file, whenever 2 computers talk to each other, that's like file transfer protocols. And we want those things to be secure. It's the specifications, it's the rules that dictate whether or not that's secure or whether or not that's insecure. One of the primary motivations is making security posture accessible to businesses, whether it's a big business or whether it's a small business. Auditing is really expensive. Hiring the people to audit and to make sure that your systems are secure is really expensive. Small businesses deserve to be just as secure as large businesses. My goal with this project is to make something that allows those small businesses to have a pretty good shot at remaining secure and remaining within NIST compliance in an easier way. It's automating that process. Let's move on. So again, this is just the presentation overview. We're going to talk about like project scope, which I kind of already covered, 800-171. And I also included a technology stack, and I didn't know why at first, but Brendan is here, so that's probably why I included a technology stack just for him. Here's the project background. Critical importance of good security posture. Every business needs this. If you send an email and it's not secure, if for whatever reason your email isn't encrypted in transmission, all of your data is just out there. You need things to be able to determine whether or not your system is secure, if it's like on a firewall level, a registry level, anything like that. Security posture is of utmost importance for any business.
Like I said, auditing is expensive for most businesses. It costs a lot of money, and a lot of businesses don't have that money to spend. So again, goal here, making this compliance accessible drives this project forward. And like it says there on the slide too, I love cybersecurity, but I also love policy. And I found a project in which I can incorporate the two of those things together. It was a golden opportunity, and specification automation is rich, it's growing, and a lot of people are now using Pascal, which is what I used for this. Here's the technology stack. I programmed basically this whole thing in Go 1.2. JRPC is for inter-service communication. I used not the same PDF generation that Bennett did. Mine was WKHTML to PDF, just basically generates a PDF report after the whole process goes through. I use PowerShell to scrape everything. And as you'll see in the technology demo, there will be a pop-up that asks for administrative privileges. My project is also kind of malware, but it's malware for your protection. Because even if you hit no, sometimes it'll still run as administrator. So your permission doesn't matter with my technology. But yeah, I use PowerShell to gather system information from your registry, from just trying to determine what type of computer it is. He uses PowerShell scripting for that. And then the reporting and compliance framework is NIST SP 800-171. And then there's OWASP-inspired fields for upload, application, and OSCAL framework was used to make this NIST specification machine readable. So it takes plain text specifications, like the rules and regulations, and makes it so your computer can actually read that, go through your system, and determine whether or not it's compliant. Let's move on. This is the system architecture, and this is what I recommend everyone do. Research deeply first, and then draw a diagram of how you want your program to go. This looks really pretty. This is not my project. About half this stuff doesn't even exist anymore, just because time constraints, because it just didn't fit with the project. We don't have databases because I don't want your data. You probably don't want me having your data either. It just generates to a PDF. I want to, at the recommendation of Professor Glass, make it to where you can plug in a module and make it sort of compliant with Jira. So if you have like a Jira workflow, you can run this scan. It'll scan your system, determine whether it's compliant. If it's non-compliant, or if it is compliant, it'll send it to your Jira workflow. Let your cybersecurity teams know what they need to remediate, what they need to mitigate. But yeah, the UI doesn't exist. This is a .exe file that runs a command line interface. But that's all it really needs. Later on, I do want to have a dashboard that kind of shows your history of compliance, like where you've remained compliant consistently, if you've changed something to where like you're no longer in compliance, but you were before. Something like that would be very helpful, I think, for a lot of people. But doing that without actually using a database that I would have to maintain or the company themselves would have to maintain is rather difficult. And again, like I said, I don't want your info. So let's move on to a live demonstration. Isn't that so fancy? It's not on Jira. I have to go to my Windows Explorer and hope that this works. My computer's non-compliant. You can kind of see that there at the bottom, but let's get a more detailed view of that. Remember, we go over here. Look at that, compliance report has been generated. Let's open it up. What's it say? It says that I'm not compliant. We already saw that. If it'll open. Oh, there we go. I'm unique. I don't use Adobe Acrobat because I don't like all the ads in AI. So this is the Industry report. It generates a serial number for it. Gives you an executive summary. Compliance score 50%. Not very good. FIPS compliance unknown. Anonymous access disabled. Here's the findings. So control 3138. Implement cryptographic mechanisms to prevent unauthorized disclosure of CY during transmission. That's not enabled on my computer. And honestly, I can't find the setting to enable it. So I'm going to remain in non-compliance for a while. Employ FIPS validated cryptography when used to protect the confidentiality, integrity, or authenticity of information system components. Also fail. But my computer knows that I'm the one that's using it, so That's in compliance. We're good there. And then the administrative notes, this report was generated with elevator privileges. This is sort of the high-level overview of the report. You would send it to your boss because he doesn't want to actually read the details. So for those of you who want to see kind of what this looks like, this is Go, and Go is really pretty. I really like it because it's not Java. Java is really wordy. This is what the sort of OSCAL framework looks like within Go. It has your control ID, it has the description, it has a compliance, it gives it a severity level. If your compliance equals false, basically if you're not compliant, it'll give you a negative score, or it'll give you a score according to whether you're compliant or according to whether you're not compliant. So those are kind of what that looks like. That's what that looks like. Let's get back into presentation. Lessons learned. Unique problems. Look for a unique problem. They exist everywhere in cybersecurity. Take on the task. This is also like my advice to the next class slide. Look for unique problems. Take on, because they exist everywhere. Every business has one. Every side of the industry has a unique problem. Look at the contemporary solutions if they exist. Like I said, automating these sorts of auditing processes, it's a growing field as people move more towards not wanting to do the manual labor behind it. And use something new. I didn't even know Golang existed before I started this project, and now I do. Now I can write it, and it's a lot of fun actually. I prefer it over any other language that I've used so far. But use something new, use a different framework, whatever it is, just challenge yourself. This was definitely a challenge for me, and it took quite a long time to actually get through it. Research and plan deeply. The first step to any project is to research everything. What's the best language for this sort of project? Because this was going through systems, because it needed to be pretty high efficiency. Golang was just kind of the language that I landed on. So research deeply, plan deeply, write a diagram. You might not achieve everything in the diagram. I don't have a dashboard. I don't have a database. So write a diagram so you have an idea of where you want your project to go, whether it's what you end up achieving at the very end. I prioritized not failing college and just getting my project done, over achieving everything in the diagram. But plan, research, draw a diagram. It's really fun. Challenges that I overcame, life was a pretty big one that I overcame because things kept happening that prevented me from actually working on my project. At one point, I had to take an antibiotic, and that made my body want to cosplay as Bob the Tomato. It was not fun at all. I was out of commission for like 2 weeks because of that. Another one, the only solution to that was just remaining diligent. Another one was maintaining motivation. Actually getting a project to work in the first place was really difficult, and I kind of didn't want to do it anymore because I was like, this is stupid. There's a comma that's been missing for like a whole week and I can't find it. Shout out to Perplexity for finding it for me, because I don't think that I could have gotten through that hurdle had it not. And then frankly, this was just a huge project from the beginning. NIST SP 800-171, I did not get all the specifications in there. I got 3. There's hundreds. It was a big project. I was like, I can do it. I can do it all by myself. You can't. But I think it was good that I bit off more than I could chew, because the solution to that was simply trimming it down to what actually still presented what I wanted my project to be, what the vision for my project was, while also pushing myself further into computer science than I thought was possible. So bite off more than you can chew, because it's a good thing to do. Oh, next steps. I kind of forgot that I had this slide. Next steps, I want to bring more people into this. I want to actually make this into something that's deployable, that people can use, because I think it's important that businesses maintain a good security posture. And for a lot of businesses, it's not possible because of finances. They're small, but they still live in a cyber world, and people in that world want to take their stuff, and it'll cost a lot of money. Last year for the Hub City Innovation Cup, I did a similar thing, or at least drew the outline for a similar thing for HIPAA. HIPAA's a huge thing, and if you're caught slipping, whether you're a small pediatric clinic or whether you're a large hospital, you'll get fined the same amount. So And that's a lot of money because, but for good reason, it's kind of greedy whenever it comes to their fines. But that's difficult to maintain if you're a small hospital or a large hospital. So bringing more people into this, making it actually accessible to people for automating the auditing process, I think it's really important to maintain compliance with these frameworks. Thank you for your time and attention. Any questions?
Okay, now when you started this project, you were talking about languages and you were using something else at the beginning. Why did you switch?
So at first I kind of wanted to look into using Rust, and then I looked at Rust, and I wanted nothing to do with it, so I quit it immediately.
What was that about?
It's a very large learning curve that I didn't want to tackle right at first. And honestly, the benefits of using it were marginal compared to a much easier language like Golang.
It makes you consider more at once, a lot more at once.
Yeah, so just for the functionality of my project, I didn't need all that. So I just wanted to go. It was simpler. I didn't need Rust, and thank goodness. What a toxic language.
Aw, we gotta throw hands on that.
Yeah.
So you mentioned OzCal. Can you describe a little bit what it is or why you use it?
Yeah, so OSCAL, let me see if I can remember the acronym. Open Security Language, Open Security Control Assessment Language. So it kind of does what I want to do, but it's just a framework. It's not actually doing what I want to do. So OSCAL allows you to take things like NIST specifications, so regulations, and it makes it machine readable. It allows for your computer to take plain text documents, whether it's 853, which if you've been in like Dr. Thatcher, Professor Glass's classes, you've touched on 853 or 853B. It takes those specifications and it makes it to where your computer can read it and produce something from it. The documentation for OSCAL is treacherous to actually read through, and finding anything useful about it, it's also pretty treacherous. That was probably the bulk of my research, was finding out what this thing is, even though I know it's useful, and how can I use it. So, yeah.
All right. Well, thank you very much.
No problem.
We have a couple minutes if y'all need to get snack, and you'll get snack.
Don't realize that doesn't do it.
Josh, it looks like you can get really to get started. So first than everyone.
People at South By, I don't know if they did all of them.
See, now I'm tempted not to, if you didn't come, I can't find anything that you filled out to make you watch the whole 4-hour YouTube stream.
Do you still have the video from last year? Can I have a copy of it?
You want just your part? Or the whole thing?
Yeah, just my part. That'd be amazing. My mom wanted it. I never did get a video of it.
Yeah, I still have it. Just remind me. I'll think I can remember it again tomorrow. Any water? Then you'll decide.
Except for the first presentation.
So.
Now that you're thinking about that.
It's technically described in such a way that the answer is just strong if they're by themselves. Yes.
I mean, I guess that's,
They're always.
I mean, I guess the argument is.
That's the thing about machines.
Yes.
I guess they should always behave the same way.
I didn't know that I should have expressed it.
It's so awful.
Let's get into the ethics. A group of players, and then say there's two or more people working together. Or two or more animals. This is just Google. Google says you're wrong.
Google's too big now. They consider what a team.
Yeah.
Because they're biased. I tried to say psychology and I was supposed to opposite. Yeah, the two physics. That thing's it's trying to leave. Oh. Like fell out of its foot.
It came off on the set tomorrow. There we go.
Yeah, they're just thick foam boards.
But why?
Visual break. Well,
Yes.
no, that's so that you're looking at somebody, you're not looking at
I guess.
the leg sitting down on the table. The visual breaks.
I think we should all opt for angling the tables forwards.
Yeah, until you put your drink on it.
No, I certainly you put a lid.
But keeps your drink. You're
Yeah,
not from
student
doing
here,
it.
your opinion isn't valid.
Just
15
to 20 degrees, just enough so that you can never have drinks.
Your pin just. They're okay, I would say raw.
Everything they did that. It'd be brilliant though. Stay in the picture.
They have that in Vegas, yeah. The seats that you could barely sit down on for waiting for your McDonald's.
Have you seen some of the new airline designs?
No,
where they've got you in a sort of squat and your
Yes,
feet
they
is
had
like
that,
4 inches deep.
in Vegas, they had that at McDonald's for waiting for your food. It's like a 4-inch seat and it's got 30 degrees forwards. The most uncomfortable thing
I'm
is.
talking about putting them on airplanes.
You'd rather stand.
Well, you basically stand. All right, you ready? Sure. All right, so next we have Samuel McEwen and his senior project, the ticket tracker. So let's hear it for Samuel.
Thank you. Good afternoon. I'm Samuel McEwen. This is my project, Ticket Tracker. We'll try to get through the overviews and technologies a little quicker because the demo, that's where it's really at. So, just basic overview. Ticket Tracker is a ticket management system designed primarily for personal and small business use. It can be used to create, manage, and store work order, customer service, and employee information. When creating a ticket, you must assign a customer and a service, and you can assign any employees. You can filter and sort tickets by specified criteria in order to make organizing a little bit easier. I'll try to show off as many of these features as I can in the demo, but for the sake of time, I cannot show absolutely everything. So, the technologies I used to create this app included Python, Nice GUI, Pewee, and SQLite. Basic Python was used to create the back end, Nice GUI was used to create the front end, and Pewee was used to interact with the SQLite database. To go into a little more detail, Nice GUI is a Python library that lets you write your front-end code using Python. That's putting it simply. This is great because it abstracts all of the HTML, CSS, and JavaScript, allowing you to write the entire front-end and back-end all within a single Python file. It is really cool. I honestly recommend you check it out. If you want to learn more about that, you can go to the documentation or you can bother Brendan because he knows a lot about it. Pewee, also a Python library, is a small yet powerful ORM, which stands for Object Relational Mapping, and it allows you to interact with the database using more of an object-oriented Python code, kind of like using classes and methods
as opposed to having to write SQL. And finally, of course, I use SQLite as my database. It's a very lightweight database perfect for smaller applications, and so it fit my use case really, really well. Now, moving on to the actual demo. We've got, over here, we got our main page. I'll quickly move through each of the pages, and then I'll demonstrate creating a customer, editing a customer, creating a ticket, and then editing a ticket, and then filtering and sorting. I won't go into too much about the services or employees just because it operates kind of on the same basic mechanics as the customer and ticket, so we'll just do that for time's sake. So we got our list of customers. Well, actually, I'll go through all of them first. So you can see here we got a navigation menu, but got your tickets, got your customers, your services, your employees, and finally you've got employee assignments. So this would be like where all your assignments for each ticket, the employees assigned to the ticket, it's just stored here just so you can see it. But let's create a customer quickly. So we'll create a quick customer. We'll just do John Doe, and you can have an email, so jdoe@gmail.com. You can put a phone number in. We'll just do 901-456-7891. And then a billing address, 12234. We'll do Union Road, Jackson, Tennessee. You can save that, and you can see it is immediately put into the database and reflected without requiring a page refresh, which is, again, another nice functionality of Nice because we let you do that. So we'll come over here to edit. We can just put the customer ID in here, get customer, and you can see all the information here. So maybe we want to change the email. Maybe instead of this, he changed emails, and his primary contact is going to be johndoe@my.uu.edu. Let's say that's the email he wants us to use. So come over here, and you can see that change is reflected. So now we have a customer. Let's come over here to the tickets, and we'll create a new ticket. So we got our customer, service, address, description, any employees, notes, and scheduling. So we'll come over here to customers. You can see all of our customers here. The guy we just created, there he is. Click him. A service, we'll give this guy landscape. He wants to do maybe some landscaping. He wants a landscape done for him. We can put in an address, or if it's the same as the billing address, we just come over here to this house, click it, automatically grabs the address from the customer table. Maybe you want a basic description. The service, in the service table, it has descriptions of what each of the services are, but maybe you want to be a little more specific here. So maybe we want to put something like customer wants trees trimmed in front yard. And we're here to employees. Let's say we want to assign some employees. So this guy and this guy we want to assign. And then any additional notes that you might want for tracking the progress of the ticket. So maybe we want to put something like park on street. Maybe we want to put something, bring extra equipment. Any kind of thing you would want to put just to keep track of things related to this work order you can put here. We can schedule it. So let's say we want to schedule it for the month of June. We'll put it for June 12th. And we can come over here, click save. And there's our ticket. You can see this assignment created in success. The assignment created is essentially just saying that the employees were successfully assigned to the ticket, because that is technically a separate operation happening. Now you can see you've got your basic information here on the customer, or on the ticket. So you got your customer, your service, the address, description, which is assigned to those notes that we added. You've also got some other information like when the ticket was created, when it was last modified, of course when it's scheduled, and the complete date, which it's not complete, so there's no date. You've got the status up here, and you've got whether or not the ticket is active. Now something also is this notes section is scrollable. So you can put as much as you want here, and it doesn't impact the size of the actual ticket cards here. But let's say we need to make some changes. We come over here to this ticket. We can, of course, add any additional information here. Maybe we want to change the ticket status. Maybe now it's in progress. or complete. So we'll complete the ticket, save, and you can see the status is now complete and the date has changed to reflect when it was completed. Maybe, we no longer need this ticket, so we are going to now set it to being inactive. Over here, inactive, ticket's gone. Over here, inactive tickets, there it is. So we will bring that back here right now. And then we'll get on to filtering. We'll filter some of this stuff. So let's say we want to filter by landscape tickets. Over here, let's save. See, all of these tickets are landscape. Maybe we want to filter down a little further. Maybe we also want to filter by customer. So we grab that customer that we just created. And there we go. There's his ticket. Come over here, reset. All your filters are gone. Maybe you want to filter by date. So let's find all of the tickets that are scheduled in the month of June. So we come over here, June, grab all this, grab this range, and then here's the tickets in the month of June. So it's pretty cool. It's pretty useful for filtering again. Sorting, same kind of deal. We can choose how we want these tickets laid out. By default, they are by created date in descending order, so the newest tickets will be on the top. We can, of course, change that to ascending, and then our oldest tickets will be at the top. If we want to schedule filter by maybe scheduled dates, so we want maybe descending, so the tickets that are scheduled farthest out, we got that there. You can reset that. And that is about as much as I can get through with this demo for right now. So here, so lessons learned, advice, next steps. I learned that scope management is hard. It's really, really easy to let scope creep make its way into your project, and it's really important to have a plan and to make sure that everything you are working on is relevant to the goals that you have set. Because if you start looking at everything that might be really cool to add, you're going to realize that you've got way too much, and it's just not going to work. At the same time, although planning is very important, plans can change. You need to be able to adapt when your plan, when needed, and as you go, because sometimes you may find that something you thought was going to be feasible turns out to be infeasible, and you need to be able to adapt to that. Especially when initially planning the project. As Professor Glass had said, you don't know what you don't know. So when making the initial plans for your project, you won't be able to account for every obstacle. And being able to adapt to overcome these challenges is a very valuable skill. Going forward, I'd like to refine much of the code in this project. The code I wrote changed and improved as I learned better, more efficient ways of doing things. Much of the early code has not been updated to reflect those new skills. So I'd also like to add some general quality of life improvements, just some little things here and there. Basically, everything that was outside of the scope originally, I now want to start to get to doing. So some of those things being adding pages. So basically, that tickets there's only a certain number of tickets per page, and you would scroll through the pages, because as it is right now, all of the tickets are on one single page, and you can imagine if you've got 2,000 tickets, that's not ideal. I'd want to add some sort of search bar, search mechanic, so instead of, just to make it a little easier for finding very specific things, you can just search stuff up, and then it would pull up things that match whatever you're searching for. And also, I'd like to add some form of authentication and user control, because as it stands right now, this is not secure. I would never want to use this or put any sort of real customer data into this, because it's not secure. But yeah, this project was a big learning curve. It was really challenging, but that was, I think, for the best. This was actually, this was the first major project, really one of the first times I ever really used Python. And this project was written 100% in Python. So I know how to write Python. That's pretty nice. But so again, like others have said, to sort of reiterate, pick something that will challenge you and that you will learn from, and that things that will teach you skills that you can take with you into the industry. But yeah, that's about everything I had. So are there any questions?
What makes this better than other ticket trackers currently out there?
That's a good question. It really doesn't. There's really nothing. I made it. It's pretty cool. This is a good template. But in terms of what makes it better, to be honest, if I were actually going to need a ticket management system, I would probably not choose this one in the current state that it's in, because again, there's no security. Everything is exposed.
Just encrypt your SQL identity. It'll be fine.
Right. But yeah, I'm hoping, if I really were to take this and run with it, maybe I could actually deploy it at some point and maybe, I might be able to have people actually use it. But in its current state, this is more of as I've been calling it, this is more of a proof of concept than anything else. You could definitely use it for, if you are running it on a secure network, sure. But, I might use this myself for just managing tasks and whatnot.
What's the big risk of security here? You mentioned that you're worried about security. What's your biggest fear?
Customer data, real customer data is being put into this, and if you have access to this application.
Oh, I guess there's no users.
No.
Okay, that's the concern.
If you have access to this application, you have access to everything in it, and everything in the data.
We just need to run one instance per user, is what I mean.
Right. So there are things that can be done, but again, security, that was way outside the scope of what I was trying to accomplish with this. But yeah. Anything else?
What's the biggest thing that surprised you in the project?
Documentation. How much documentation reading there was. I was expecting the majority of working on this project to be coding. That is not true. The vast majority of working on this project was me reading documentation, trying to figure out what on earth I was doing, how on earth to use these libraries. So I'd say maybe about 40% of this was actually writing code, and the other 60% was trying to figure out what I'm doing and how to use these tools.
I know that's made much worse with Nice GUI because there's 3 separate documentation pages for all the different sub-libraries.
You can't just use Nice GUI's documentation because it relies on other things like
Quasar.
It uses Quasar, Tailwind, Fast API.
Yeah.
I think it uses Vue. Things like that.
Maybe
So-
Quasar uses Vue for their components. I think it might be what it is.
Yeah. Lots of documentation.
Yeah.
Anything else?
All right, well, thank you very much.
Automatically set up the web content section, and then it tracks away the event. So that way, it automatically creates an item that button and items that it did.
That's what I was gonna do, but I figured I'd ask you.
But it looks nice. It looks
Drug that out a little bit, just I figured something like that.
It does it. It's very useful. There's the problem of everyone wants to use AI for web apps, and then if you try to use AI for web apps, you get every time. The gradients with the emojis and the circle block, it all smells like this. I went to some website. Yeah, I'll see you do it. So I was doing it. I was like, look, you're a science website or AI generator. You've got gradient buttons. Nobody in the right mind puts a gradient on a button ever. Unless it's an ask AI, and then they make it a gradient because AI does that. Feel something.
Hey, what's up? What are you doing? I'm doing well. How are you?
There was something that I wanted that they did not really could be consistent
The stage ends.
Just realized in here, just figure out why. Need a bottle of water or anything?
Oh, when they go together or when they go out? I think we should go out.
Need a tour of this.
Oh, no.
How do you live? Don't forget, please fill out the evaluation forms for any of the presentations that you've witnessed, observed, liked, disliked. I want to hear it all.
Is that for all?
Any presentation that you want to do. So, the more the merrier, that way I have more data. Like more data. Don't limit yourself. I mean, limit yourself to one per presentation, but don't limit yourself to how many.
I limit myself to all the answers on the form.
You
I followed in all
that's
buckets.
Just shade them all in.
There's something
Turn them
like
all into clocks with different pie representations.
that.
All right, you ready to go?
I'm ready, yeah.
All right, so we're going to continue with Joe Garretson and his project called Blur. Everybody say hello to Joe.
So yeah, my name is Joe Garretson, and this is my game Blur. It's a 2D video game made in the Unity game engine. So let's start here. What is Blur? So it's a top-down action-adventure game with real-time combat with like a dreamlike aesthetic. I took a lot of inspiration from like psychological horror games like Silent Hill, and then I kind of had the gameplay of like early Zelda games. That's kind of what my like kind of mashed up Frankenstein's monster idea came from. So why did I choose this project? Well, I just kind of wanted to find out like what would it take for me to make a game entirely by myself, start to finish. Like what would I learn? What would I gain from it? I'm someone who's been into game development since like high school, and I've worked on a lot of like small games with like teams or like in class, and I've never like made a game just by myself from the beginning to the end. So I just figured this would be a good time to kind of experiment and see what I found out. So yeah, there's a lot of tools I used to create this game. I used the Unity game engine, which if you don't know what that's like, which everyone here probably knows, but if you don't know what Unity is, it's kind of like Photoshop or like game or like a GarageBand, but for making games exclusively. The Unity game engine uses mostly the C# language. So there was a lot of learning C# in that programming. I used the program BaseSprite for the pixel art in the game. That was all done by me, and then I also followed a few YouTube tutorials for like specific mechanics that I wanted to figure out how to implement. So the vision. So my vision for this game is to have like a very strong artistic direction, but also very engaging gameplay. There's a lot of games out there that kind of sacrifice one or the other. Very pretty to look at, very, kind of kind of like, walking sims, you walk around, it's very atmospheric, cool, but like there's really not a lot to do. And then on the other side, there's a lot of really cool like gameplay. It's like very engaging, but like visually it's kind of like all over the place. So I wanted to make something that didn't prioritize one over the other. So some of my goals for this game were to make multiple areas, to make multiple characters, enemies, have a fully fleshed out combat, have a story, and have randomly generated dungeons. So those bottom two bullet points, they didn't really pan out. Like the story is very early stages. Like there's several things that like I know I want to hit, several story beats, and like the end I have a basic idea of, but as far as actually implementing that in the game, it's not really implemented at this stage. And also the randomly generated dungeons was just kind of a bit too ambitious, and I kind of realized that like about 2 weeks in, I was like, that's not going to get done. But there's still like kind of groundwork for that to be in the game in the future. But now I'm going to go over a specific mechanic that I have in the game. That's the combat. So the combat, I'm going to move around this giant board. You have this enemy prefab that has a collider right here on its head. That's its hitbox. So if you get too close to that, then it will damage you and knock you back. And then if you use your weapon, this sword thing, and you hit it, if your collider hits with that collider, it knocks the enemy back and it takes damage. So both the enemy and the sword have these variables that you can adjust in the Unity Inspector to kind of change how much damage you want to do, how much knockback you want to do. And then I'll show that right now, demonstration. This is the start menu. There's not much going on there, but here when you open up the game, you can walk around and you see you have an enemy in the bottom left. If you get within a certain range, start to follow you. And like you might have seen, he already hit me once. I got a little too close, but he hits me and I take 5 damage and I go back a bit. You can see there's also like a little splash text that shows how much damage you take. And then if I get close enough and I use the sword, then I can deal damage to him if I hit him a few times. Also, you can see that after a while he gets bored and goes back to where he started. That can all be changed. Let's see, I finally killed him. I got 1 experience for him. But something I wanted to showcase is the variables. So you might not be able to see it on the screen if you're sitting in the back, but I can just explain. If I open up the small enemy and I go to the hitbox, I can change how much damage it does just in the inspector. So say I wanted to do 10 damage and I wanted to do like 2 times knockback. That's going to push me back a lot. And I can do the same thing to the weapon where I can change the damage. I'm going to keep the damage at 1 and then push it back. All right, I'm going to put the knockback at 2. So if I run the game now, I go over here, if he touches me, I get flung back. And you can't actually die in this build because, I'm presenting it, I don't want to die. I'm not like the Cuphead thing. Anyways, if you go up to it and you hit it and he gets knocked back like crazy. So I'm going to do that a few times until he dies. I think he has 5 health right now. But yeah, so that's the combat. And now that I have the demo open, it shows some other features. I have a currency system. If you go to this chest and you press E, you get 15 feathers. The reason it's feathers and not like coins is because I'm just trying to really like hone in on this kind of dream, abstract, surreal vibe. And also normally it would be a little bit darker. And even now, like the glare is a little bit bad, but I made it brighter so that you could actually see it in the daytime. Hopefully you all can see it well. But if you go up to this door, there is a collider, an invisible collider. And if you get close enough to it in range and you interact with it, you go to a new scene. So this scene is like a dungeon type of scene where it will be puzzles and multiple enemies and items and whatnot. This would be kind of where the randomly generated dungeons come in. I'll make like several kind of variations of these kind of levels that will spawn kind of to create like a maze. So that will be kind of a small section. But yeah, so if I walk over here, I can show the next scene. which is this forest area. And the kind of like jarring, like scene switching nature of it, I kind of want to have implemented in a full build. I just want it to like be like a little bit jarring when you go from scene to scene and location to location, kind of like, you know, like if you're in an actual like dream where like, you don't really know what's going on. And it's very bizarre and surreal. But there also, I don't want to make it too abstract. I don't make it too weird because that might be like frustrating or people might be like a bit turned off by that. So to kind of fight against that, I'm going to have a very structured, like, it's like a thread of a story that you can very clearly follow throughout the game with like NPCs and the cutscenes and whatnot. You know, right now I don't really have that, but that's kind of the goal of that there. Let's see. So that's most of the gameplay I've shown, or I'm going to show. But so like I said, all the pixel art was made by me, and I took advantage of the Unity tile palette or tile map system, which I really love. Like, it's so easy to use. You just click one of these things and you like paint the whole scene. You can put so many different attributes. You can like decide if there's collision. You can decide if you walk over it, if you walk under it. You layer things. That is super helpful. I love that feature in Unity. Yeah. Another thing is all these scripts. There's a lot of scripts involved. I'm not really going to go over them because, you know, time. So, but there was a lot of C# that I had to learn. A lot of learning inheritance functions, how C# works with Unity. Shout out to Dr. Ruby's C# class. That was very well timed. I took that last semester, so it was like a very well timed class for this project. But as far as that goes, I think I'm going to go last slide here. Because there's a lot to cover here. There's what I learned, the time management is crazy. I like kind of the biggest thing I needed to do is kind of plan out when and what I'm going to work on. And I have a lot of trouble with like kind of creating a calendar and like following a structure like that. So kind of what I opted to do is just create a list of things that need to be done. And then I would go through the list, and if I got stuck on something, I would go to a completely different thing. Because kind of the advantage of working by yourself on a project this big is that it's such a, like, there's so much, like, there's so many things going on, so many moving parts. So if I work on, like, animation or something, and I just get stuck, like, this won't work, this doesn't look right, I can just stop that and then go on to some other part of the project, like, maybe like designing like how an enemy attacks or something, creating code for that. There's also unreliable tutorials. I followed a lot of tutorials and some of them kind of suck. There are some times where I'd be following a tutorial and it would be telling me like just ways to do stuff that I was like, that's ridiculous. Why would I do that? Like, these are so weird. And there's honestly something I need to go back into my project and fix, because I followed this one tutorial that was a lot about just making a top-down game, and it had me make like it had me do so much like strange like tagging and inheritance that I felt like was really unnecessary. So that's something I'm gonna have to probably go back and look at. But anyways, my point being is that you gotta really like you kind of need to know more before you follow the tutorials, because otherwise you're just kind of blindly following stuff that, you know, might not really be great. Other than that, about the future of the game, right now I have like a pretty good base for the game. Like, it's obviously not finished, there's a lot to do, but I've laid the groundwork for that. There's a lot. But like from now on out, it's kind of the easy part in a way. I can just kind of design. And well, actually, you know what? Scratch that. It's not the easy part. But now it's now that the base things are done, you know, I can create more dungeons. I can like the workflow is just kind of going to be a bit better from here on out. But yeah, so also I want to eventually create a soundtrack And sound design, none of that is implemented right now, so that's something I want to dive into. I want to do a lot more puzzles and challenges in the dungeons, stuff that's not just the combat. But with the combat, I want to kind of make it more interesting. I want to add shields, more weapons, add different enemy types. I want to make it very like, I want you to be able to parry attacks, I want to be able to time attacks. I want to make it very kind of skill-based and sort of like, quick reaction speeds, that type of thing. Also the story, I need to write out the full story, character dialogue and whatnot. Kind of what I learned throughout this process is I'm not really good at that part. So, one of the biggest things I gained from this project was learning my strengths and my weaknesses in game design and in game development as a whole. And I learned story writing isn't really my thing. So, either I can improve on that, or I can get some help from some friends or from people who that's more of their strong suit. And that is kind of my kind of big takeaway is that there's things in game development that I'm more capable at than others. There's things in game development that I enjoy more than others. I really enjoy creating the levels. I enjoy creating the artwork. I really enjoy creating the mechanics. Like with combat, I really love going and tweaking things and making things just feel more natural. There's a lot of work to be done, of course, but that was my most. Those parts of the development process I really enjoyed. And like I said, the story part I did not enjoy. So, yeah, that's mostly it. If there's any questions, that would be a good time. Yes.
You said that this is going to be like some sort of a horror game, because you were inspired by different horror games like Silent Hill. How scary are you planning on making this game? Or are you going to try and fully scare people, or are you just trying to give creepy atmosphere?
Yeah, much more like a creepy atmosphere. I don't really want it to be a scary game. I just want it to be like you're alluding to more atmospheric games like Silent Hill and Resident Evil. Obviously, they're horror games, but they really thrive in their just kind of creepy atmosphere, making you feel scared even when there's not anything scary happening. So I kind of want to try to tap into that.
Can you talk more about the C# code? Maybe don't go through the script, but just what were the things you needed C# to do that Unity couldn't handle?
Yeah, so a lot of that, Unity really doesn't do, it does a lot, but it doesn't really do a lot in terms of actually making things move and operate. So for instance, with the player, I had to add a player script that actually would calculate when you press an input, how much if it what direction you could make it move and whatnot. I had to do that I basically had to make a script for everything that's in the game. But it's kind of hard to go over specifics, but for instance, I had to make a collidable script, which, in hindsight, I don't really know if I would do it the same way, but I had a collidable script that I could use to be a parent script to other scripts, like the script that transfers the player to a different scene anytime you're colliding, or the NPC and the chest, all that inherits from collidable, inherits attributes that collidable has. So just stuff like that. A lot of inheritance was really, there's a lot of inheritance, and yeah.
Alright.
So
Okay, so can you speak a little bit more to procedurally generated levels? What about that's so challenging to create?
Honestly, I'm not really sure, because I looked at just kind of the scope of the project, and I was like, this is something I want to do eventually, but I'm not going to have the time. I want to focus on other things first, because I feel like that's not as important to really do at this moment. But so I honestly don't know how difficult that's going to be, but I'm excited to find out.
All right, well, thank you very much.
I'll send you an email about it if I remember.
Thank you. Good to see you.
You too.
You were here the whole time? Oh my God.
Alright, ice cream.
Are you screaming? It's the new, watching this. Oh, yeah, well, that's because this is your primary screen, and your primary screen is, unless you. Is it a, yeah.
This is.
There you go. Yes. That's your back. Okay. Yeah. You're still on the line. Take it. Yeah. Yeah. It's kind of frustrating. All right, so welcome Will Veneable and his senior project, anti-cheating software for online multiplayer games. So everyone welcome Will.
All right, let's see, this was my senior project. It was a research paper for anti-cheating software in online multiplayer video games. Let's get started. Let's see. So what is anti-cheating software? Why is it important? Anti-cheating software is software that game developers implement into their games or implement as a third-party application that runs at the same time as you're playing a game in order to prevent cheating in any form in a multiplayer sense. It is meant to protect the integrity of games and the competitive fairness and the revenue of the developer. Let's see. The issues and why I chose this topic. The issues and importance of anti-cheating software is that they often have a distrust in how people view them and their history. It has been long since criticized for not being enough to actually prevent cheating, and there's also the growing security and privacy risks for the users. I chose this topic because I like video games and have personally experienced some cheaters in some of the games I've played in my time. Let's see, these are the types of anti-cheating software used today. This is not every single one, but these are the most widely known ones that are employed, and most people have heard of at least some of these. So first off, we have Anti-Cheat Expert. They're owned by Tencent. And we have Easy Anti-Cheat. Then we have Riot Vanguard. Then we have Punk Buster, Valve Anti-Cheat, Battle Eye, and Imperfect Game Guard. Some of these you probably have heard of, some of these you probably have not. Many of them are more widely used than others as we get Easy Anti-Cheat and, well, Anti-Cheat Expert. They are more widely used than some of the other ones. Ones like Riot Vanguard are only used for 2 games. And Valve Anti-Cheat is also mostly just used by Valve Corporation, although there are a few ones that have been used over the years. Right. Let's see. So we will be going over the usage of anti-cheating software. Obviously, the purpose of anti-cheating software is to prevent cheating in online multiplayer games. They work to maintain competitive integrity of video games and esports tournaments. Things that they can do is they detect and block memory, editing, injections, and exploits. Attempts to reduce behavior, cheating behaviors such as using aimbots, ESPs, wall hacks, and scripting. Many of them support real-time analysis with AI detection. Many of them have varying levels of how advanced that detection is. Some of them work in real time, some of them do not. Some of them only work after the fact. After a cheater has already been caught. Many of them also work at the kernel level of the computer, which is the lowest level that most applications can work at. And this allows for a deeper, more accurate detection of certain types of cheats that work at the lower levels of the computer. All right. Security risks. So one of the main things about anti-cheating software is that, especially as technology advances these days, it gets very difficult to actually. It's very difficult to actually prevent cheating without violating the privacy of users. So obviously, having an application work at the kernel level of your computer can't always introduce new vulnerabilities. If the software was breached and someone can have access to that. Oftentimes, these anti-cheating software, they employ data collection, which is normal for many computer applications. Things that they will collect include hardware identifiers, IP addresses, and system fingerprints. A lot of this is actually, I say it's normal, it's considered normal. It is a privacy violation, but it is just something that many computer applications do. Depending on what other games you play, many of these anti-cheats will conflict with others, and they will try to fight each other, or just they will block legitimate programs from launching, such as reporting software if you're streaming. Also, from it, they can also result in many false positives. Player distrust increases heavily when these systems appear to be more intrusive than others, as people do not like things on their computers. Like I mentioned before, if the software was breached, it can become an attack vector, so it just opens vulnerabilities for people's computers. It also can interfere with drivers, overlays, and other security tools. Like if you have an antivirus, it will, it can interfere with it. If you have it active at all times, it will interfere with it working. Right. What ways do developers prevent/mitigate cheats? There's a variety of different techniques. Obviously, we have the kernel level stuff. Some of them employ behavioral analysis. They try to prevent memory modification in games. Some of them have region tracking, where they can block accounts based on the region if they have access to certain, or if they have access to the fingerprints of your computer. Sometimes they can just tell what region you're in, regardless of if you're using a VPN. They also try to guard against malicious file tampering and file injection. So if you inject certain cheats into games, they can detect that. They also have server-side validation checks. This is for the game servers, for the actual multiplayer games, where they run the software through the server, and then it checks the game integrity from both your side and also the server side. Some of them have machine learning and AI-based behavior tracking models. Some of them enforce security measures such as TPM, Secure Boot, and IOMMU. Specifically, Riot Vanguard enforces Secure Boot when you were playing games like Valorant, which is the main game that is used for that system. They also encrypt game code. Many developers also implement servers dedicated as cheating lobbies to keep them out of the regular servers. This does not necessarily have to do with the anti-cheating software, but they could flag these specific servers to not detect any of the cheats that are going on, and so they can keep the actual regular servers free of cheaters. At least that's what they hope. Developers often use databases of cheats and exploits and keep track to keep track of all of the methods and things, and also the accounts that people have. And they have like a reporting system where they excuse me, they keep track of all of these different people that had cheated in the past. All right, here we're going to look at some videos and examples of cheats. All right, so this one is an aimbot. This is specifically Call of Duty Warzone. As you can see, this person is the crosshair of the gun with the mouse is snapping to targets. That is a very unnatural movement. Even the people with the best skills you can have essentially cannot do this perfectly. There's always some level of human error. So this is one way of maybe seeing cheats if you have them perfected if the person's screaming, such as they are reporting or screaming. So you can see it's just, next is a wall. This is a wall, and this is specifically Counter-Strike 2. Normally, you are not supposed to be able to see if there is another player, and you can also, if there's another player behind the wall, and then also you can see their vision. This is a script. So this is actually what normal bullet spray looks like. You're using this specific gun, and when you employ a script or a macro, you can stop the recoil. Oh, excuse me. Yeah, so you can. Yeah, so we will stop the recoil. This is like normal recoil. And this will make it, as you can see, it is concentrated to one point where it can help you win matches more effectively. Let's see. Here's another example of it where it's just concentrated in one. This one is also another example of a macro where this person is using a specific gun that is not able to rapid fire, and with like a macro for the mouse, it is able to fire almost instantly, and that obviously is not normal, and it gives you a very, very big advantage. And then, so this is a very weird instance of cheating. This is what is known as backtracking. So depending on the way the game works, the positioning of a player is not always just in one place. Sometimes they have these little ghosts. As you can see these all these phantoms, where the player can still be interacted with. In this case, it is a gun being shot, where you can get eliminated. As you can see, even if you're not actually at that point. So as you can see, this example of this, and you can also, it can also last for about 200 milliseconds, which doesn't seem like a huge amount of time, but it is actually a lot for this type of thing. Let's see. Next, there's also forward tracking, which is a little bit less common, but it also, this is just very, it is pretty. This is an example of software working in real time. So you see this person again, and they discovered that one of their teammates is actually cheating. So they actually, he goes to block them from moving, and he actually reported them in an earlier part of the actual video. So as you can see, the anti-cheating software worked, and the cheater was actually removed from the match. Here we have another example where this is a Valorant game. So this person is playing, and then they just whether or not they knew it or not, a cheater was encountered in the match, and the anti-cheat is about to start working. Yeah, so the match is canceled. Not every anti-cheat does this when a cheater is detected. Some of them don't stop the game, some of them do. This example also is of software messing up and not working. Lots of times people just, or when people are trying to just play a game, sometimes the software just bugs out and just does not work. This is the, as your last thing said, this is the blue screen of death. We don't know exactly what caused this, but we do know that there was a problem with the anti-cheat. It's also here in the next one. This is it's Apex Legends. So this player, she was actually false banned. There was no evidence on screen actually to know whether or not she was actually cheating, but it was later confirmed that she actually was not cheating at all. So there's just a few examples of anti-cheating either working or not working. Let's see. Let's go on to the future for anti-cheating software. Honestly, with advancements in AI technology, there is potential for things like behavior analysis, pattern recognition, and adaptive detection. Using things like blockchain, which have immutable logs, these can record player actions on the blockchain, so activities are documented. Having decentralized verification, in which no single entity has control over the game data, which reduces the risk of tampering. Smart contracts are able to automate certain aspects of the process for anti-cheats, such as automatically banning players when detected. There's also, we're also going to look at the advances of cheating, image recognition can allow AIs to identify relevant information and capture the game stream. This does not actually read the game memory, so it is more difficult to detect. Decision and operation. AI will make decisions such as moving, aiming, and shooting based on identified information and implement the cheats by simulating real player influence to see to make it as close to what a real player would do and make it almost impossible to detect by the anti-cheat. Another one, the last one we have is direct memory access, which involves modifying the game data directly through accessing the memory by ways of specialized hardware devices, such as a PCIe and a USB device. So these just can also bypass the security of the actual operating system. Let's see. Lastly, we have lessons learned. Takeaways. My takeaways from the research was people have just huge distrust for also technology in general, and they often think that they're useless, especially when it comes to cheats. Money, obviously, money is a huge factor, and the anti-cheats are actually a money hole. They do not actually make money. They just are something that it's literally a liability. So they often have to. Many games are not often employed. Let's see. Reactivity, similar to antivirus systems, the development of anti-cheating software is reactive. So it is constantly trying to adapt, evolve to catch up with the cheaters. The future, it is very uncertain with AI, with the advancement of AI technology potentially playing a huge role. Solutions, there is no single solution. There are many variables that must be taken into account. There's just a great need to balance the security and privacy of users, while also making the software actually work and powerful enough to actually combat cheating. Does anyone have any questions?
Is there a better solution to catch cheaters than software level imaging? Or is this the best way?
As of now, I think that it is highly dependent on the game, the players, and the developers, what they can implement. Because there are some examples of instances of people putting things in their games, like depending on certain game mechanics, like if a player tries to use something, sometimes the game mechanic or the game will punish the player for using that. Honestly, I really don't know. One of the main scopes of this project was that the future is so uncertain since we don't know what technology is, how it's going to evolve, and what's going to happen. We just know that software anti-cheating is a pretty good way, at least if it actually does work. So how oftentimes, even if anti-cheats, even if it actually works for some players, many players don't see it working at all. So it's like there's this discrepancy between what's actually going on and what people think is going on. Any other questions?
Joe.
Since it's sort of like an arms race between the cheaters and the anti-cheat, what do you think is like kind of winning?
It's really hard to determine what winning is because there are always going to be people cheating in video games. So in some ways, winning could potentially be really bad for users in that they would allow even deeper access to their computers. It could help prevent cheating, but also that is a huge privacy violation. And even if many companies or people, the developers say that the anti-cheat does not collect data or does not do things that are malicious, there's always a chance for people outside of the developers to actually do malicious things on someone's computer. So any other questions?
All right. Well, thank you very much.
Thank you.
The wireless. If you want to gamble with casting, you can change it to control. That's maybe 50-50, is it?
You ready? Well, hi everyone. I'm Dr. Ruby. Timothy White has been working with me on astrophysics research projects, and so I will pick it over to you.
Hi, everybody. Thanks for being here. As Dr. Ruby said, I've been working with him on this research project. Title is Constraining the Ionized Outflow of Markarian 266 Southwest with Hubble Narrowband Imaging. You may be thinking, what on earth does that mean? So let's talk about it. So, starting broadly, Markarian 266, also called NGC 5256, is a galaxy merger, which means it's two galaxies actively colliding with each other. And it's about 390 million light years from Earth. A couple of definitions. So an AGN, or active galactic nuclei, is a supermassive black hole that is actively accreting material. So it's supermassive black hole is just a black hole that is 100,000 times the mass of the sun or more. Markarian 266 is a dual AGN, which means that it has an active galactic nucleus in both the northeast and the southwest nucleus. And you can see those here. So this is the northeast and this is the southwest. Because it's looking at the sky, if you point left, you're pointing east. So east is left, west is right. So we can do that. And then lastly, so the biconical outflow of ionized gas created by the southwest nucleus see here, we'll see it better in later pictures, but you can kind of see the southeast conical outflow here. This way. So narrowband imaging is a method of collecting light using different filters. The data that I looked at was using 4 different filters, 2 wideband, 2 narrowband. So wideband filter is collecting light over a wide range of wavelengths. And the 2 wideband filters that I was looking at were centered at 435 nanometers and at 814 nanometers. And then the 2 narrowband filters that I was looking at data from were centered at 505 nanometers, which is the wavelength at which O3 emits light. O3 is doubly ionized oxygen. And then 656 nanometers is the wavelength which H alpha is emitting light, and that's singly ionized hydrogen. So you can see where those are in the light spectrum here, and then on the left side, just gives you an idea of, okay, yeah, the paler, wider ones in the back are examples of wideband filters that are collecting light over a wide range, and then you've got the narrow spikes that are the narrowband filters, which are restricted to just within a few nanometers of that central wavelength. So this is the imagery data that I was looking at. It's from Hubble Space Telescope. The top left there is the O3, and then you've got H alpha, and then the 2 wideband filters on the bottom. And you can see, so these are pictures of the same thing, but you can see different parts based on which light is being filtered out. So the top left, you can see those are the areas where it's predominantly O3, and then these are the areas it's predominantly H alpha. And then the bottom 2 is just more of a general picture. So these are useful for identifying where different what the makeup of different parts of the galaxy merger are. And then you can also combine them in what's called the false color composite, which is where you assign colors to the different filtered data and you overlay it. So you can see all of the data together, but you can still differentiate between the different types of gas and whatnot. So on the left and the right, actually, those images are on the same color scale. But here in the middle, you can see the middle left is O3 in blue, H alpha in red, and then the 435 wideband in gray. And then this one here is O3 in red, H alpha in blue, and then 814 wideband in gray. So finally, what does it mean to constrain the outflow from Carter 266 Southwest? So this is the thrust of my project, which is using new Hubble data to obtain more accurate parameters for the southwest outflow cone, southeast outflow cone of the southwest nucleus. So, as I pointed out earlier, you can see a little better in this picture, the 2 conical outflows from this nucleus. So this is the one that I was looking at, the southeast nucleus. And the goal was to measure it accurately, and then to use those values to rework some calculations for the mass outflow rate, which is just how much mass is being ejected from the galaxy by way of this outflow over time. And then the dynamical time, which is a measurement of how long this outflow has been active. So here's a graphic just to give a better idea. This is from Dr. Ruby's paper on Mark 266. So we're not looking straight down at the top, nor straight at the edge of the galaxy. It's at an angle something like this. And you've got one outflow cone on this side and then back behind it like that. So here's much zoomed in. This is the O3 data because that's what was showing up clearest to get good measurements of this cone. So here's a measurement just of the north side of that cone. I was able to get both the length, 4.31 roughly arc seconds, and then also use the dimensions of this triangle to get the angle at which it's not quite horizontal, it's slightly below. So the angle there is about 3.27 degrees. And then went ahead and measured the south side at about 5.22 arc seconds, and then again used the dimensions of this triangle to calculate the opening angle, which is just this angle up here at the top of the cone. And then I went ahead and subtracted that 3.27 degrees because again, it's not quite horizontal. So the opening angle is about 57 degrees. And then lastly, I got a measurement for what the height of this cone would be, just going straight down the middle at about 4.3 arc seconds. And then those arc second values, based on the distance that the galaxy merger is from us, you can calculate from the scale of arc second, which is a measurement of arc, to kiloparsecs, which is an actual measurement of distance. So you can see those translated values there, and then here's just a table with all those values. And then I just overlaid that in this lovely green so you can see it and get an idea of the geometry behind here and where those values all fit. So with those values measured, I went ahead and did several calculations. So the first one is to get the lateral surface area of the cone, which is everything but the actual circle at the bottom, because the gas is being ejected in that shell shape, not in the full volume of the cone. So I did a calculation for that based on the opening angle and the observed height, and then used that to calculate the mass outflow rate, which we talked about earlier. And then the mass outflow rate can be used to calculate the kinematic power of the outflow, which is a metric that can be used to determine if this outflow is being powered by AGN or if it's being powered by star formation in the distant galaxy. And then the last thing I calculated was the dynamical time of the outflow, which, as I mentioned earlier, is how long this outflow has been active. These are simple parameters that I use in my calculations, and these are all taken again from Dr. paper on the subject. Firstly, the lateral surface area. So just taking the equation for the lateral surface area of the cone, rearranging it to have it based on the values that or the variables that I had values for, and then plugging those in yielded a value of about 57.32 kiloparsecs squared. The mass outflow rate, this is an equation taken from Dr. Rubin's paper, which you got from another paper. So the two there is accounting for the biconical nature of the outflow. So I got the lateral surface area of one cone, but there are two, so you multiply by two, and that's the mass of the proton, and then density is a value for basically the density of gas. The Vmax is how fast the gas is moving, and that is derived from kinematic evaluation of the data. The A is the lateral surface area, and then N is a filling factor. So with my values plugged in, I got 4.47 times 10 to the 26 kilograms per second, which is about 6,902 solar masses per unit. And then plugging that into the equation for the kinematic power of the outflow, I got a value of about 5.37 times 10 to the 37 watts. And then for the dynamical time, just plugging in this basic kinematic equation for the relation of time and distance and speed, rearranging that and plugging in the height which is going to be the farthest distance that a gas has traveled, and then the maximum velocity you can get it done for the time, which is about 4.9 minutes in 6 years. So here are all of those values in the center column, and then these are the values from Dr. Ruby's paper. He was deriving those values from older Hubble imagery. And if I can go back here. So in the imagery he was looking at, it looks like this was the entirety of the cone right here. And then in this viewer imagery, you can see that it actually extends much farther than that. So that's the major difference in our results there. But comparing these, so you can see the value for the Laminar surface area is much larger, therefore the mass outflow rate is also much larger, and kinematic power, again, an order of magnitude larger. So the conclusion that Dr. Reed came to in his paper with the kinematic power of the outflow is the value he got was already an order of magnitude larger than the available power from star formation. So he concluded that this outflow is indeed powered by the AGN and not by star formation. And my value being, again, an order of magnitude larger only confirms that. And then with the dynamic time of the outflow, you can see my value is about 5 million years as opposed to is 1.7. But again, there, the time scale of the galaxy merger is on the order of 100 million years. So the dynamical time value is, the point of that is to see, okay, is this, was this outflow triggered by the actual galaxy merger itself beginning, or is it triggered by, again, the AGN turning on? And since the timescale of the galaxy merger is so much larger than either of our values, it seems logical to conclude that it is being triggered by the AGN, not by the merger itself. So, yeah, largely, my results just confirm what Dr. Ruby concluded in his paper. So, any questions?
Talk more about what you learned about astrophysics, and maybe that's a little bit broad. But.
Yeah, I mean, it's been fun just going from, our first couple of meetings feeling pretty totally lost to actually kind of understanding a little bit of what's going on. Obviously, I got a pretty small snapshot of the entire field, but it was really neat not only to learn more about Mark 266 and what's going on there, but also just to get an idea of what actually doing astrophysics looks like.
You might have said right during the beginning of the session, I might have just said, but how far away is this star?
90 million light years. Yeah. Very far.
Given that this involved a whole lot of calculations, what did you use to do the calculations? Like, how much of it was a manual calculation versus a computer doing the calculations?
So it was all manual. Most of it I wrote out and then just plugged into a calculator.
I'm assuming you weren't surprised by the results, given that your mentor had already looked at this phenomenon and concluded similarly. But were you hoping to maybe prove him wrong, or?
Well, I mean, I was hoping not to prove him wrong, because that would be awkward. I feel like that would just be mean, but maybe not. No. But yes, I mean, I expected to get values that would concur with his. And then again, as I mentioned, just looking at the difference in imagery and the difference in the size of the cone you can see and measure, expecting larger values for all these things.
Being proven wrong is usually more interesting.
Yeah, I mean, scientists like that, right? And that's why I asked the question.
Awkward for me, maybe not. Any other questions?
Also, it's yours. All right, so next we got Moses Chu presenting on investigating manga galaxy properties using UMAP dimensionality reduction.
Dr. Ruby said, my name is Moses, and my project is investigating manga galaxy properties using UMAP dimensionality reduction. This is NGC 2623. It's a famous merger that is about 263 million light years away from us. And we can tell this merger interacting galaxies by the tidal waves over here, and then all the gases running around, and then the rabbit tails right here and over there. So we can tell it's a merger because it's relatively closer to us, and then we can take images, sharp images with round telescopes and space telescopes, and we can tell it's a merger by its shape. But what if it's even further away from us? If it's really far away from us, we can use spectroscopic data such as gas kinematics, star formation rate, and gas ionization to identify them. And that is the motivation for our project. Instead of just looking at the galaxy from the outside, we can use high-dimensional spectroscopic data to reveal meaningful patterns and potentially identify galaxies that may be strong merger candidates. And this is the outline of my project. First, I'll introduce the two astronomical surveys behind the project, SDXS and MANGA. And then I'll introduce you to the main goal of the project, and I'll explain the dimensional reduction tool I used for the project. And then I'll interpret the clusters, and then I'll pick up two of the most interesting clusters I found in the project. And then I'll explain the future work and then conclusion for the project. So the two astronomical surveys behind this project are SDSS, or Sloan Digital Sky Survey. It is one of the most important sky surveys we have right now. The goal of this survey is to map the universe in a systematic way by collecting images and spectra for huge numbers of objects, including stars, quasars, and galaxies. So the purpose of this project is, rather than just looking at a few galaxies at a time, SDSS gave astronomers a way to study hundreds or thousands of galaxies in a consistent format, and that makes this survey are really ideal for statistical and machine learning based analysis. And within SDSS Manga, or we call it Mapping Nearby Galaxies at Apache Point Observatory, that's the survey I used for my project. Manga is different from a traditional survey because they use integral field spectroscopy. Instead of just taking one spectrum for each galaxy, Manga uses a bundle of optical fibers called an integral field unit to collect spectra across many positions in the same galaxy. This way, Manga does not just tell us what the galaxy looks like overall. Instead, it tells us about the properties inside the galaxies and initial movements within the galaxy. And that's what's made Manga such a rich data set, but also makes it really hard to analyze using simple methods. For this project, the features I used to train my model includes 103 quantities relating to star velocities and velocity distribution, stellar velocity, H alpha gas velocity and gas dispersion, and a large set of spectral indices. And with that, we come to the question of the project. The question is, can we use dimensionality reduction to uncover meaningful structure in Manga galaxy data, and can those structures help us identify interesting physical patterns of galaxies, especially mergers or galaxies that shows unusual kinematics? So the goal of the project is to apply dimensionality reduction to high-dimensional galaxy data to reveal patterns that are difficult to see directly. And then the main problem with modern astronomy is that we have so many data in our data sets, but there's just not enough research project to look into them and identify them. So if the machine learning model we use in this project can identify mergers or galaxies that have interesting shapes, then we can apply more data into the machine. So with all the information we have collected from SDSS and Manga, how do we actually compare thousands of galaxies at once? As I mentioned earlier, each galaxy comes with at least 103 different features, and it just makes it really hard to interpret a pattern by eye. So that's when we apply UMAP to the data sets. UMAP helps us to reduce the complex data sets into a form we can visualize, and once galaxies are placed in the lower dimensional space, clustering helps us to see which one shares similar physical characteristics. And what is UMAP? UMAP stands for Uniform Manifold Approximation Projection. It is a nonlinear dimensionality reduction technique that takes data with many variables and compresses it into a low-dimensional map so we can visualize it. The easiest way to think about UMAP is we live in a 3D dimensional space, so we have X, Y, and Z axis. But all the galaxies in our data set have 103 dimensions. So what UMAP doing here is basically compress the 103 dimensions down to 2 dimensions or even 3 dimensions, while preserving the structure, and then help us to find a pattern within the data sets. And then here's my method pipeline, how I did my project. First, we begin with 103 features data sets for galaxies. And then I used principal component analysis, or PCA, to reduce noise and capture dominant variance. And then I applied UMAP to the data sets and preserves local nonlinear similarities in 2D. And then after that, I used a density clustering technique to identify groups in low-dimensional map. And then the problem with machine learning, and especially UMAP, is it takes away all of the features. So after UMAP transform all the data sets you have, it takes away all the features. So it is very hard to identify why UMAP clustered all these galaxies in one group, and then the others just in a different group. So the interpretation part of the project is really also really important. And here's the UMAP projection of the Manga data set.
And you can see every little point on the map is a galaxy. And galaxies that are closer together have similar physical properties. And then the more apart they are, that means they have more differences within them. So how do we interpret the clusters? We can do that by just looking at the galaxy images and stellar velocity map. And we have 4 different kinds of galaxies within the data sets. We have border disks, surrounding rotators, patchy or complex galaxies, and compact rotators. For example, cluster 0, 1, 4, 6, and cluster 9 appears to have galaxies with very clean velocity gradients, and they're relatively symmetric. And then cluster 2 and 8, they have really strong rotators, and clusters 5, 7, 10, and 11, they have a patchier, and the velocity of the galaxies in the clusters appears to be more asymmetric. The clusters I would put more emphasis on this project would be cluster -1 and cluster 3. The reason I put more emphasis on cluster -1 is it groups all the outliers within the UMAP. These are the galaxies that do not fit into the main cluster, and that suggests that they have unusual combinations of stellar velocity structure and other galaxy features. Which means this cluster may be important because it might contain some more interesting objects. They might be disturbed, or they might be interacting with other galaxies as just separates them from the main clusters. And the other cluster that I would focus on is cluster 3. It stands out as a group of galaxies that appear to be rotating, but not like galaxies in other clusters. Many of the galaxies still have disk-like stellar velocity patterns, but the maps are more irregular and disturbed, which suggests that this cluster may represent galaxies in a more transitional state. So I would say that the galaxies in this cluster might be a result of old merger activities. So overall, we can make a conclusion that UMAP does give us a structured plot for our high-dimensional data, and all the galaxies fall into recognizable groups that actually correspond to physical meaningful differences. And this project did show us that dimensionality reduction can be a powerful tool for interpreting complex galaxy data. Using UMAP and clustering techniques, I was able to organize galaxies into groups that appear to affect meaningful differences. And the cluster suggests that UMAP is separating galaxies according to patterns such as rotation and translational behaviors. And among all the groups, I identified cluster -1 and 3, and they stand out as the strongest follow-on targets. However, UMAP did not give us direct proof of which galaxies are mergers. The input data in this project tell us about the telicity, stellar and gas kinematics, and spectral indices. And these data are not enough to identify mergers. So instead of saying we use UMAP to identify mergers, we can say that UMAP help us to identify galaxy clusters, and then some clusters may contain possible mergers. And for future studies, I would say we can put more sample size into the UMAP and see whether some of clusters are they going to be stable, or are they going to separate into different groups. And then another future work would be adding new features to it. We can put more AGA-related features or merger-related features into the machine models. And then we can also have a closer look at cluster -1 and 3, because there's a higher chance that we could actually find mergers. Thank you for your time. Questions?
What
cluster group would our galaxy fall into?
I'm actually not sure about that.
Okay.
It's not in our data set, I don't think so.
Okay.
Did you find anything surprising in your data that you weren't expecting?
It does. So there's one cluster the map did identify like they're all like disc-shaped galaxies, and then they all have a similar shape in the cluster. So I think using all the spatial indices, UMAP did find some interesting features, but it's just not what I'm looking for. So.
When collecting the data set for the mountain galaxies, I had some trouble getting the data set. I'm wondering if you had like similar problems to me when it comes to
I
like
got my data set from so.
I did all the hard work.
Yeah. Special thanks to you.
Thanks, everybody.
So that should conclude this session of Symposium. So thank you all for your time and your effort and your attention and your presentations. So big round of applause for everybody. Thank you.